For most of human history, the universe felt distant but orderly. Stars moved across the sky in predictable patterns. Galaxies followed gravity. Time unfolded forward. Even when discoveries surprised us, they eventually settled into place, explained by equations and models that made the cosmos feel coherent again. But something has changed. Over the past months, astronomers have been reporting observations that don't feel dramatic at first glance. There are no explosions visible to the naked eye, no cinematic disasters, no immediate danger. Instead, there is a quieter disturbance. Data that technically makes sense, yet feels deeply wrong. If you enjoy calm science that slowly turns unsettling, take a moment to like the video, subscribe, and leave a comment. It helps this channel reach others who enjoy questioning what we think we understand. Now consider this. Astronomy depends on expectations. We expect where certain objects should be. We expect how fast they should move. We expect what environments they should exist in. When those expectations fail, the universe doesn't announce it loudly. It whispers. Recently, astronomers noticed something subtle while analyzing deep space observations. A bright, compact source appeared offset from the center of a distant galaxy. At first, this wasn't alarming. Galaxies are messy places. Dust clouds obscure cores. Foreground objects overlap background ones. Misalignments happen. But this one didn't resolve itself with closer inspection. Instead, it became stranger. The object wasn't just misplaced. It was moving. Not drifting. Not orbiting. Moving away. The more data accumulated, the clearer it became that this object wasn't a star, or a cluster, or a supernova remnant. Its mass estimates placed it far beyond anything small. It was consistent with a supermassive black hole. That realization alone should have stopped the analysis. Supermassive black holes don't roam freely. They sit at the gravitational centers of galaxies, anchored by the mass of billions of stars. Removing one is like pulling the keystone out of an arch. In theory, it can happen. In simulations, under extreme conditions. But seeing real evidence of it is something else entirely. The data suggested this black hole wasn't just displaced. It was traveling through space at an extraordinary speed, millions of kilometers per hour, fast enough to eventually leave its host galaxy behind. And that raises a deeply uncomfortable question. If this black hole can be ejected, how many others might have been lost this way in the universe's history? Because a galaxy without a central black hole is not the same object anymore. Its structure changes, its future changes, its stability changes. But that's only the beginning. As astronomers followed the black hole's path, they noticed something unexpected trailing behind it. A faint line, a subtle glow. At first glance, it looked like noise, but statistical analysis revealed something astonishing. Along the path this black hole had traveled, gas appeared compressed, heated, triggered. Stars were forming in its wake. A black hole, typically imagined as a destroyer of structure, was instead leaving behind a thin ribbon of creation. This isn't how intuition prepares us to think about black holes. It suggests that extreme objects don't just erase information or matter. They can reorganize it in ways we don't fully understand. And if this is happening once, it may not be unique, which leads to an even more unsettling realization. We only see what our instruments are sensitive enough to detect. If a supermassive black hole can quietly escape a galaxy, leaving only a faint trail behind, how many similar events might be invisible to us? How many galaxies might appear normal, but are missing something essential? The universe doesn't signal loss clearly. It allows absence to blend in, and absence is harder to detect than presence. This isn't an isolated feeling. Around the same time, astronomers working with radio telescopes noticed another anomaly, one that arrived not as an image, but as a signal, a brief burst of radio energy, lasting only milliseconds, yet releasing an enormous amount of power. Events like this have been recorded before, and they already challenge understanding. But this one carried an additional discomfort. Its origin. The signal appeared to come from a region of space where violent cosmic activity should be rare. An old galaxy, quiet, stable, long past its era of explosive star formation. Most explanations for such powerful signals rely on young, highly energetic objects. Massive stars collapsing into neutron stars, magnetized remnants spinning rapidly. Those don't belong in ancient galaxies. And yet the signal was there, real, measured independently, verified. Scientists proposed explanations carefully, one by one. Perhaps it was a rare, leftover object from an earlier epoch. Perhaps an interaction we don't fully understand. Perhaps something new entirely. Each idea accounted for part of the observation. None accounted for all of it. And what makes this unsettling isn't the lack of explanation. Science thrives on unanswered questions. What makes it unsettling is the growing pattern. These aren't dramatic violations of physics. They are quiet mismatches. The universe behaving legally, but unexpectedly. Like finding footprints where no one should have walked. As more data comes in, researchers are noticing that these edge cases are becoming more frequent. Not enough to rewrite textbooks, enough to make footnotes multiply, enough to create discomfort. Because when enough footnotes pile up, they begin to suggest something deeper, that our models may be accurate, but incomplete. And incompleteness at this scale is not trivial. It means there may be entire categories of behavior the universe allows that we haven't mapped yet. Behaviors that don't announce themselves with spectacle. They hide in averages. They hide in margins. They hide in things moving slightly too fast, forming slightly too early, or appearing slightly where they shouldn't. The universe isn't screaming at us. It's calmly continuing, while revealing cracks in our expectations. And that may be the most terrifying part, because it means we're not missing the universe's loudest moments. We're missing its quiet ones. Another assumption we rarely question is time. Not time as we experience it day to day, but cosmic time. Astronomy relies on timelines. What forms first? What takes longer? What should not exist until much later? Stars need time to form. Galaxies need time to organize. Complex structures need billions of years of gradual evolution. At least, that's what our models say. But over the last months, telescopes have begun reporting objects that seem to be ahead of schedule. Not slightly, uncomfortably. Some of the most distant galaxies ever observed appear far more mature than expected. Their light comes from an era when the universe was supposed to be young, chaotic, and simple. Yet these galaxies already show signs of structure, defined shapes, dense star populations, unexpected chemical complexity. In isolation, each observation could be explained away. Measurement uncertainties exist. Distances are hard to pin down. Early galaxies may behave differently than nearby ones. But as more data accumulates, the pattern becomes harder to ignore. These objects don't look like cosmic infants. They look experienced, which forces a disturbing question. How did they get there so fast? One possibility is that our timelines are slightly off. That star formation in the early universe was more efficient than we thought. That matter clumped faster. That gravity worked a little harder in the beginning. All of that is plausible, but every adjustment has consequences. Speed up early galaxy formation too much, and other predictions break. Change early star behavior, and background radiation patterns shift. Alter chemistry timelines, and element abundances stop matching observations. Cosmology is a tightly balanced system. When one part moves, everything else feels it. That's why these recent findings are uncomfortable. They don't just ask for small tweaks. They suggest that something fundamental about early cosmic behavior may still be missing from our models. And missing pieces at the beginning of time echo forward. If galaxies formed earlier than expected, then black holes may have grown earlier too. If stars burned faster, they may have seeded space with heavy elements sooner. If structure emerged earlier, then the universe may have become complex far sooner than we thought. This compresses the cosmic timeline, It makes the universe feel rushed, as if it didn't follow the slow, patient unfolding we imagined. And that sense of haste becomes even stranger when paired with another recent observation. Astronomers studying distant cosmic explosions notice something unusual. Not their energy, not their brightness, their duration. One event, detected across multiple instruments, released intense radiation for hours. Not seconds, not minutes, hours. This doesn't fit neatly into known categories. Most violent cosmic explosions are brief. Their power comes from how quickly energy is released. Stretch the duration too long, and the mechanism no longer makes sense. Yet the data showed a sustained event, maintaining output far longer than models predicted. Scientists carefully checked their instruments, looked for interference, considered rare alignment effects, but the signal remained real, measured, uncomfortable. The proposed explanations are cautious. Perhaps an unusual collapse, perhaps a massive star interacting with its surroundings in an unexpected way, perhaps something we haven't classified yet. What makes this unsettling isn't that explanations don't exist. It's that none of them feel satisfying. They solve pieces of the puzzle but leave gaps. And gaps are dangerous in cosmology because they tend to grow. This brings us to a quieter, more subtle category of recent discoveries. Not dramatic objects, not explosive events, but patterns. When astronomers map the large-scale structure of the universe, they expect randomness at extreme scales. Clusters form, filaments stretch, voids open, but overall, the universe should look statistically similar in all directions. That assumption underpins modern cosmology. Yet recent surveys have revealed large-scale alignments that are difficult to dismiss, structures that seem oriented, patterns that persist across distances too large for coordination. These are not walls or edges. They're suggestions, hints that something about the universe's structure may not be entirely random. Again, the data doesn't scream. It whispers, and scientists respond appropriately, with caution, with skepticism, with restraint. But the fact remains, independent surveys are starting to notice similar features, which raises an unsettling possibility. What if the universe has a memory, not in the conscious sense, but in the sense that early conditions left imprints larger and more organized than we expected? If that's true, then uniformity may be an approximation, not a rule, and that changes how we interpret everything. From cosmic background radiation, to galaxy distribution, to the assumptions that let us calculate the universe's age and fate. None of this implies disaster. None of this suggests immediate danger. But it does suggest humility, because what these recent discoveries have in common is not shock value. It's quiet contradiction. They sit just close enough to our expectations to be believable, and just far enough to make us uneasy. They don't break physics. They stretch it. They don't overthrow models. They reveal blind spots. And blind spots are unsettling precisely because we don't know what else they hide. As observers, we like to believe we're watching the universe clearly. But these findings suggest something else. That we're catching glimpses of behavior we weren't looking for. That reality isn't obligated to behave in the most convenient way. And that understanding may always lag behind observation. Because some of the strangest recent findings aren't about what we see, but about what we can't. There is a comforting belief most people carry without realizing it, that what we see is in some meaningful sense complete, not complete in detail, but complete in scope. That if something truly important were happening in the universe, we would eventually see it, detect it, measure it, catalog it. Modern astronomy reinforces this belief. We build larger telescopes, we widen the spectrum, we listen instead of only looking. We map the sky with increasing precision. It creates the impression that the universe is becoming transparent. But recent discoveries are quietly challenging that assumption, not by revealing dramatic new objects, but by revealing how much can still happen unseen. One of the most unsettling developments in recent months comes from what astronomers call transient events, phenomena that appear briefly, leave a trace, and then vanish. For decades, astronomers assumed that most energetic cosmic events announced themselves loudly. Supernovae flare across galaxies, gamma-ray bursts light up detectors, active black holes pour radiation into space. But now, telescopes are beginning to notice events that don't behave that way, signals that appear suddenly, linger just long enough to be detected, and then fade before their nature can be fully understood. In some cases, these events are only noticed because instruments were already pointed in the right direction by chance. That alone is unsettling. It suggests that the universe may be producing phenomena that are both powerful and easy to miss. One recent example involved a faint but persistent signal detected across multiple wavelengths. It wasn't strong enough to trigger alerts. It wasn't bright enough to dominate its surroundings. It was subtle. Yet when astronomers examined it more closely, they realized it did not fit any known category. It wasn't a star. It wasn't a galaxy. It wasn't a supernova afterglow. It wasn't a typical black hole signature. Its energy output was wrong. Its duration was wrong. Its environment was wrong. At first, the data was treated cautiously. Noise happens, artifacts appear, instruments drift. But independent observatories saw it too. Different instruments, different teams, same anomaly. That's when the discomfort set in. Because when multiple systems agree, the universe is telling you something, even if you don't yet know what. What made this particular detection disturbing wasn't its power, but its context. It appeared in a region of space that should have been quiet. No recent star formation, no obvious massive objects. EEG's no history of violent interactions. And yet something there released energy in a way that suggested an underlying process we don't yet recognize. Not new physics, necessarily, but unfamiliar behavior. This kind of discovery forces astronomers into an uncomfortable position. They must choose between two unsettling possibilities. Either the universe contains entire classes of phenomena we haven't identified yet, or the phenomena we think we understand are capable of behaving in ways we didn't anticipate. Both options imply a gap, and gaps are dangerous when they hide in plain sight. Another recent development deepens this unease. Astronomers have long relied on indirect evidence. We infer mass from motion. We infer structure from light bending. We infer energy from subtle shifts in spectra. Inference works well until it doesn't. In the past months, gravitational studies of certain galaxy clusters have revealed mass distributions that don't align with visible matter in expected ways. This isn't new in principle. Dark matter has been invoked for decades. What's new is the pattern. Some clusters appear to contain concentrations of mass where nothing visible exists. Not even faint gas, not even weak radiation. Just gravity acting alone. In isolation, this would be filed under dark matter behavior. But in several recent cases, the distributions don't match standard dark matter simulations either. They're too compact, too localized, too structured. Astronomers hesitate to speculate publicly, but internally, the discomfort is clear. Because gravity without visible cause challenges one of our most basic instincts, that influence must come from something we can eventually point to. These mass concentrations don't announce themselves. They don't shine. They don't emit. They simply affect, which leads to an unsettling thought. What if the universe is not just filled with things we can't see, but with processes we can't easily categorize? Not missing objects, missing behaviors. As telescopes become more sensitive, the problem doesn't shrink. It grows, because sensitivity reveals not only more detail, but more anomalies. And anomalies have a habit of clustering. Another quiet discovery from recent surveys involves cosmic voids, the vast empty regions between galaxy clusters. For a long time, these voids were treated as passive, places where nothing much happens. But new observations suggest that voids may be more dynamic than we assumed. Subtle temperature fluctuations, unexpected motion of surrounding structures, weak signals that don't correspond to known sources. Nothing dramatic, nothing headline-worthy on its own, but enough to suggest that even emptiness may not be inert. This challenges a deep assumption that nothingness is simple, that where matter is absent, behavior is absent. The universe may not agree, and that disagreement is quiet. No explosion announces it, no clear boundary marks where understanding fails. Instead, the universe allows us to notice, slowly, that our categories may be incomplete. This brings us to perhaps the most unsettling aspect of recent discoveries. Not any single object, not any single signal, but the pattern itself. The universe seems increasingly comfortable operating at the edges of our definitions, producing objects that are almost familiar, events that are almost explainable, structures that are almost consistent. Almost. That word matters, because almost is where uncertainty lives. Almost is where confidence erodes. Almost is where fear quietly enters, not fear of danger, but fear of misunderstanding. We don't fear that the universe is hostile. We fear that it is indifferent to our frameworks, that it does not care whether we recognize its patterns. And that realization reframes discovery itself. We often imagine science as a steady march toward clarity, but these recent findings suggest a different picture, one where clarity increases. But so does complexity, where each layer of understanding reveals new behaviors we weren't looking for, where the universe doesn't become simpler as we learn more. It becomes stranger, and not in a dramatic way, in a way that slowly undermines confidence, because confidence relies on predictability. And predictability is becoming rarer at the margins. As instruments improve, the margins grow, and with them, the sense that we may only be seeing part of the story, not because the rest is hidden behind a wall, but because it exists in forms we haven't learned to recognize yet. They're about the possibility that our categories are no longer sufficient. There is a point where accumulation turns into implication. One strange object can be dismissed. One anomalous signal can be debated. One unexpected structure can be treated as coincidence. But when discoveries begin to stack quietly, independently, across different instruments and disciplines, the discomfort changes shape. It stops being about individual mysteries. It becomes about the limits of interpretation. Over the last months, astronomers have found themselves returning to an uncomfortable realization. Many of the universe's recent surprises are not extreme outliers. They sit just close enough to expectation to pass initial scrutiny. That is what makes them dangerous, because science is designed to handle extremes. It struggles more with subtleties. One recent line of investigation highlights this perfectly. Astronomers studying faint background radiation noticed deviations so small they were almost ignored. Slight temperature variations, minor anisotropies, barely above statistical noise. But these variations weren't random. They clustered, not strongly enough to declare a discovery, not weakly enough to dismiss. They existed in a narrow band where certainty dissolves. And when researchers attempted to model these deviations, something unsettling happened. No single explanation failed outright, but none succeeded fully either. Some models explained the amplitude but not the distribution. Others matched the distribution but failed on scale. Still others required assumptions that conflicted with other well-tested observations. This creates a peculiar scientific tension, not a contradiction, but a lack of closure. And closure is something we unconsciously rely on, because without it, the mind begins to ask questions it isn't trained to answer. What if the universe is not cleanly divisible into known categories? What if some phenomena exist in states that blur the line between object and process, between signal and structure, between event and background? These questions are not philosophical indulgences. They arise naturally when data resists classification. Another recent discovery deepened this unease. Astronomers monitoring stellar remnants noticed objects that behaved almost like neutron stars, but not quite. Their emissions were weaker, their timing irregular, their environments inconsistent. They didn't fit the profile of white dwarfs. They didn't behave like magnetars. They weren't typical pulsars. They occupied an in-between state, rare, unstable, hard to define, and yet multiple examples were observed, enough to suggest this wasn't a one-off. What unsettles researchers isn't the existence of new categories. Science expects that. What unsettles them is how many of these recent discoveries occupy transitional states, as if the universe is more comfortable existing between definitions than within them. This pattern repeats elsewhere. In galaxy formation studies, astronomers have identified systems that are neither clearly active nor clearly dormant. They form stars intermittently. They flare without sustaining activity. They drift between phases. These galaxies don't follow clean evolutionary tracks. They hesitate. And hesitation is difficult to model, because models prefer direction, progression, sequence, order. But hesitation implies instability. It suggests that the universe may not always move cleanly from one state to another. It may linger, oscillate, hover near thresholds. And thresholds are dangerous places. They are where small changes produce disproportionate effects, which brings us to a deeper concern underlying many recent discoveries. Not about what the universe is doing, but about how fragile our understanding might be. Modern cosmology is incredibly successful. It predicts background radiation with astonishing precision. It models large-scale structure with impressive accuracy. It explains stellar evolution across vast timescales. But success breeds assumption, and assumption can become blind. The recent wave of unsettling discoveries doesn't threaten the core of physics. That's important. They don't invalidate relativity. They don't contradict quantum mechanics. They don't demand new forces overnight. What they do is more subtle. They expose the edges, the places where our models stop being predictive and start being descriptive, where we say, this usually happens, instead of, this must happen. And the universe appears to be exploiting those gaps, quietly, without spectacle, as if it's reminding us that laws describe tendencies, not obligations. This realization changes how recent discoveries feel. They aren't terrifying because they imply danger. They're terrifying because they imply freedom. Freedom for the universe to behave in ways we didn't anticipate. Freedom to occupy states we haven't named. Freedom to produce outcomes that sit just outside our expectations. And freedom is unsettling when it applies to something as vast and indifferent as the universe. Another layer of discomfort comes from timing. Many of these discoveries are recent, not because the phenomena are new, but because our instruments are finally sensitive enough to notice them, which raises a troubling question. How long have these things been happening? How many wandering black holes passed unnoticed? How many faint signals slipped through gaps in detection? How many structures existed just below resolution limits? The universe may not be changing. Our awareness may be. And increased awareness doesn't always bring comfort. Sometimes it brings disorientation, because it reveals that the map was never complete, only sufficient. This matters because maps shape expectation, and expectation shapes interpretation. If our maps are missing regions, not because they're hidden, but because they don't fit our categories, then the universe may be more complex than we assumed. Not more violent, not more hostile, more subtle. And subtlety is harder to confront because it doesn't announce itself. It requires patience, attention, and the willingness to accept uncertainty without immediate resolution. This is where recent discoveries leave us, not at the edge of knowledge, but at the edge of confidence. Confidence that what we see is representative. Confidence that what we classify is complete. Confidence that what we expect is what the universe prefers. The universe seems indifferent to those preferences. It doesn't aim to confuse us, but it doesn't aim to reassure us either. It continues doing what it does, forming objects that almost fit, producing signals that almost make sense, arranging matter in ways that almost align with theory. Almost. That word returns again, and with it, a quiet unease. Because almost is where certainty dissolves into curiosity. And curiosity, when stretched far enough, becomes something else. A sense that understanding is provisional, that knowledge is conditional, that reality does not owe us clarity. This doesn't diminish science, it deepens it. But depth comes with weight, and weight changes how discovery feels. Recent discoveries don't shock us with spectacle. They unsettle us with implication. They suggest that the universe may not be simpler than our models, but more permissive, allowing edge cases to flourish, allowing ambiguity to persist, allowing behavior that sits between definitions. And that may be the most quietly terrifying realization of all. Not that the universe is dangerous, but that it is unconcerned with our need for neatness, but how we decide what counts. There is a quiet assumption underneath almost every scientific discovery that when something doesn't make sense, the problem is local, a faulty measurement, a missing variable, a model that needs refinement. In most cases, that assumption is correct. But recently, some astronomers have begun to wonder whether the discomfort they're feeling isn't local at all, whether it's systemic. Because many of the recent discoveries that feel unsettling share a strange property. They don't break the rules, but they appear to sit in places where the rules feel strained, as if the universe is operating comfortably near boundaries we didn't realize existed. One of the clearest examples of this comes from recent observations of extremely dense objects that blur the line between known categories. For decades, compact objects were cleanly sorted: white dwarfs, neutron stars, black holes, each defined by mass thresholds and physical behavior. Cross a certain limit and collapse becomes inevitable, or so we thought. But in the last months, astronomers have detected compact objects whose inferred masses place them in an uncomfortable gap. Too heavy to be neutron stars, too light to be black holes. This mass gap wasn't supposed to contain anything stable. It was considered a forbidden zone, a region of parameter space where matter couldn't survive without collapsing further. And yet, observations suggest objects may exist there, not hypothetically, not in simulations, but in real systems, detected through gravitational interactions and subtle emissions. At first, researchers assumed measurement error. Mass estimates are tricky. Distance uncertainties propagate. Binary interactions complicate signals. But as additional systems were observed, the pattern persisted. These objects weren't extreme outliers. They clustered. Not many, not enough to rewrite theory, enough to unsettle it. Because if stable objects can exist in the mass gap, then the clean boundaries we rely on are more porous than expected. This doesn't mean black holes aren't real. It means the path between states may be messier, and messiness introduces ambiguity. Ambiguity is uncomfortable in cosmology because it undermines classification, and classification is how we understand. A similar unease has emerged from recent studies of cosmic expansion. Not the fact that the universe is expanding that's well established, but the rate at which expansion changes over time. Independent methods of measuring cosmic expansion are beginning to disagree in subtle but persistent ways. Measurements based on the early universe suggest one value. Measurements based on the nearby universe suggest another. The discrepancy isn't large enough to declare a crisis, but it's large enough that it refuses to go away. Scientists have checked instruments, refined calibrations, reanalyzed data sets. The tension remains. This is unsettling, not because we don't know the answer. It's unsettling because both methods are internally consistent. Each works beautifully on its own. They only disagree with each other, which suggests the universe may be behaving differently at different epochs in ways we haven't fully captured. If that's true, then expansion isn't just a smooth process. It may have phases, transitions, subtle shifts that don't announce themselves dramatically, but still reshape the universe's history. And history matters because our entire understanding of cosmic age, structure formation, and fate depends on it. If expansion has behaved differently than expected, then timelines compress or stretch. Events happen earlier or later. Structures form sooner or struggle longer, which brings us back to a recurring theme in recent discoveries: timing. Several newly observed phenomena appear either too early or too late relative to expectation. Not impossibly so, uncomfortably so. They don't scream contradiction, they whisper inconsistency. And whispers are harder to confront. Another recent example involves chemical complexity. Heavy elements, those beyond hydrogen and helium, are forged in stars and spread through space by explosions. This process takes time, generations of stars, cycles of formation and death. Yet recent observations of distant objects suggest complex chemistry appearing surprisingly early. Again, not impossible, but dense, too organized, too mature. This forces scientists to ask whether early stars behaved differently, whether star formation was more violent, more efficient, or more clustered, or whether there are processes we haven't accounted for. Each possibility carries implications. Change star behavior and energy budgets shift. Change explosion rates and background radiation changes. Change chemical timelines and planet formation models adjust. Everything connects, which is why these discoveries feel heavy. They aren't isolated curiosities. They tug on threads, and pulling one thread tightens others. The universe begins to feel less like a machine with fixed settings, and more like a system with ranges. Ranges of behavior, ranges of outcomes, ranges of histories. This flexibility is not inherently frightening, but it does undermine a comforting idea that the universe follows a single, clean path. Instead, it may explore a space of possibilities, and that exploration may leave behind rare, unsettling outcomes. Another recent line of observation reinforces this. Astronomers studying extreme environments near massive objects have noticed behavior that defies simple scaling. We expect small systems to behave like larger ones, just weaker. But that assumption is breaking down. Some small systems behave too energetically. Some large systems behave too quietly. The proportionality we rely on begins to fail. This suggests that scale matters more than expected, that crossing certain thresholds changes behavior qualitatively, not just quantitatively. And thresholds, once again, are uncomfortable places. They are where small changes produce large effects, where predictability weakens, where intuition fails. This brings us to a subtle but profound shift in how recent discoveries feel. They don't tell us the universe is broken. They suggest it may be less constrained than we assumed. That physics describes allowed behavior, not guaranteed behavior. And the universe seems willing to explore the edges of what's allowed, quietly, persistently, without explanation. This reframes the idea of weird discoveries. They aren't anomalies in the sense of errors. They are anomalies in the sense of permissions we didn't realize existed. And realizing that something is permitted is different from realizing it is common. The universe may allow rare behaviors, and rarity is exactly what makes them unsettling. Because rare events evade expectation. They don't show up in averages. They hide in corners. And as our instruments improve, we are no longer blind to corners. We are starting to see what happens there, which raises a final discomfort for this section. If the universe is comfortable operating near boundaries, if it allows transitional states, if it explores edge cases, then our future discoveries may not become simpler. They may become stranger, not because reality is chaotic, but because it is permissive. And permissive systems don't owe us neat explanations. They produce outcomes. And outcomes don't ask to be understood. They simply exist. They're about what it allows us to see. There is another assumption woven so deeply into astronomy that we rarely notice it. That seeing is knowing. That once something is observed, it becomes part of the universe we understand. But recent discoveries are beginning to expose a gap between observation and comprehension, a space where things can be detected, measured, and cataloged, yet still resist meaning. Not because the data is flawed, but because the act of observing may not be as complete as we assume. Over the last months, astronomers have been confronted with the signals that are undeniably real, but strangely difficult to place within any existing framework. Some arrive briefly and vanish before context can be established. Others persist, but only weakly, as if deliberately avoiding attention. And some appear only indirectly, through effects rather than presence. One of the most unsettling categories involves objects that announce themselves only through influence. They do not emit light. They do not flare. They do not leave obvious signatures. They reveal themselves by how other things behave around them. Stars accelerate unexpectedly. Gas clouds distort. Light bends just a little more than it should. For decades, this kind of behavior was grouped under dark matter, a necessary placeholder for unseen mass. But recent observations suggest that not all unseen influences behave the same way. Some mass concentrations appear too localized, too structured, too sharp. They don't diffuse smoothly like standard models predict. Instead, they cluster, as if something compact exists there, but refuses to show itself directly. This raises an uncomfortable possibility. What if not everything that matters is visible, even indirectly? What if some aspects of reality influence outcomes without leaving clean, interpretable traces? Science prefers mechanisms that can be probed repeatedly, but these phenomena don't cooperate. They appear once, or only under specific conditions, or only when multiple variables align perfectly. That makes them resistant to experimentation. And resistance breeds uncertainty. Another recent development deepens this concern. Astronomers analyzing high-energy particle detections have noticed events arriving from directions that don't match known sources. The particles carry immense energy. They should trace back to violent environments. But when telescopes look, there is nothing. No supernova remnants, no active galaxies, no obvious engines. Just empty sky. At first, this was treated as a mapping problem. Particle trajectories bend, magnetic fields interfere, paths are distorted. But even after accounting for these effects, some arrivals remain unexplained. They don't point back to anything recognizable, which forces a strange conclusion. Either we are missing sources, or our understanding of how particles travel through space is incomplete. Both options are unsettling, because they imply that the universe may host processes that are not just unseen, but untraceable. Processes that leave outcomes without footprints. This undermines a foundational comfort. That cause can always be reconstructed from effect. In many recent cases, effect arrives alone. Context never follows. Another category of observation challenges perception itself. Astronomers have begun detecting structures that only appear under very specific observational conditions. Change the wavelength slightly, and they vanish. Shift the resolution, and they dissolve. Observe them indirectly, and they appear stronger. These objects exist at the edge of detectability. They are not illusions, but they are fragile. Their existence depends on how we look. This creates an unsettling feedback loop. We don't just observe reality, we filter it, and the filter shapes what exists for us. This isn't a philosophical statement, it's an observational one. Different instruments reveal different universes. Radio space is not infrared space. X-ray space is not optical space. And increasingly, discoveries appear in one domain and refuse to appear in others. This fragmentation complicates understanding. Because coherence across domains is how we confirm reality. When coherence fails, certainty weakens. Another recent example involves time itself, not cosmic time, observational time. Astronomers tracking certain transient signals notice that their apparent duration depends on how they are measured. Some appear short in one dataset, long in another, structured in a third. This isn't instrument error. It's perspective, at different sampling rates, different sensitivities, different thresholds. The event itself doesn't change. Our interpretation does. This raises an unsettling thought. How many phenomena do we misunderstand simply because we see them through the wrong window? Not because we lack data, but because we lack the right framing. Recent discoveries suggest that reality may not present itself consistently across scales and methods. Instead, it reveals fragments, pieces, partial truths, and those pieces don't always assemble cleanly. This challenges the idea that the observation naturally leads to understanding. It suggests that observation may be necessary, but not sufficient. Another subtle pattern has emerged. As datasets grow larger and more precise, astronomers are finding that statistical significance does not always imply interpretability. Some signals cross detection thresholds confidently. They are real beyond doubt. Yet when researchers ask what they are, the answer remains unclear. They exist without identity. That's deeply uncomfortable. Because science relies on naming, naming creates categories. Categories create understanding. But these discoveries resist naming. They sit between classifications. And without classification, prediction fails. This resistance isn't dramatic. It doesn't announce itself as a crisis. It quietly erodes confidence. Because confidence depends on the belief that everything observable can eventually be placed somewhere. Recent discoveries suggest that may not always be true. Some things may be observable without being understandable, at least not with our current tools. This realization changes the emotional texture of discovery. Instead of excitement alone, there is hesitation. Instead of clarity, there is caution. Astronomers find themselves saying things like, "We don't know what this is. It doesn't fit any known category. It may represent a new type of phenomenon." These statements are common in early discovery. What's new is their frequency. They are no longer rare. They are becoming familiar, which raises a troubling possibility that the universe may not organize itself in ways that align neatly with human classification, that our taxonomies may be approximations, not reflections, and that some aspects of reality may resist being fully captured by observation alone. This doesn't mean the universe is unknowable. It means knowing may be conditional, dependent on perspective, dependent on method, dependent on what we choose to look for, and that choice shapes discovery. Recent findings suggest that the universe may be richer than our observational frameworks allow, not because it hides things maliciously, but because it doesn't simplify itself for observers. It exists. We sample it, and sampling introduces bias. This is not new in principle, but it is becoming unavoidable in practice. As more discoveries emerge at the edge of detectability, astronomers are forced to confront the limits of inference. Not everything that influences reality announces itself clearly. Not everything that matters emits light. Not everything that exists is stable enough to study comfortably. Some phenomena appear briefly, influence outcomes, and vanish, leaving questions behind. This creates a sense of unease, not fear of the unknown, but awareness of limitation, an awareness that the universe may contain layers of behavior that our instruments glimpse only fleetingly, layers that don't align with our expectations, layers that complicate rather than clarify. And as these layers accumulate, the idea that observation leads steadily toward completeness begins to weaken. We may be seeing more than ever before, but understanding may not be keeping pace. They challenge the assumption that the universe is obligated to be fully legible to us at all. There is a subtle shift that happens when enough unanswered questions accumulate. At first, each mystery feels isolated, an anomaly here, a discrepancy there. But eventually, the mind stops treating them as separate. They begin to feel connected, not by evidence, but by implication. Recent discoveries are pushing astronomy toward that threshold, not because they contradict one another, but because they expose a shared vulnerability, the assumption that the universe is fundamentally legible, that if we observe carefully enough for long enough with precise enough instruments, Reality will eventually reveal itself clearly, but clarity is becoming harder to claim. One of the most unsettling realizations emerging from recent work is how dependent understanding is on scale. At small scales, physics behaves one way. At large scales, another. At cosmic scales, assumptions begin to thin. Astronomers have always known this in theory. What's new is how often recent observations refuse to scale smoothly. Phenomena observed locally do not always extrapolate cleanly to larger environments. Behavior that seems stable in one context becomes erratic in another. This has become particularly apparent in studies of extreme environments. Regions near massive objects, high-energy fields, or dense cosmic intersections. These environments do not simply amplify known behavior. They transform it. Processes that are predictable elsewhere become unstable. Outputs fluctuate. Relationships break down. This matters because much of modern cosmology relies on extrapolation. We study nearby systems in detail and assume the same rules apply everywhere. But recent discoveries are suggesting that assumption may be fragile. The universe may not scale politely. Another source of unease comes from how often recent findings rely on indirect inference. We don't see the phenomenon itself. We see its effects, shifts in motion, distortions in light, changes in timing. Inference has always been necessary in astronomy, but the recent wave of discoveries pushes inference further from intuition. The chain from observation to explanation grows longer. More steps, more assumptions, more places for uncertainty to hide, and uncertainty compounds. When one assumption depends on another, which depends on another, confidence becomes conditional, not false, but fragile. Another recent pattern reinforces this discomfort. Astronomers are increasingly encountering phenomena that seem to exist only briefly, not in cosmic terms but observational ones. Events that appear during narrow windows. Miss them, and they are gone. These are not rare accidents. They appear frequently enough to suggest that transient behavior may be a fundamental feature of the universe, not a statistical outlier. The universe may not be dominated by stable objects. It may be dominated by processes that flare, interact, and dissolve. And processes are harder to catalog than objects. Objects can be counted. Processes must be inferred. This shifts the nature of discovery. Instead of finding things, astronomers find moments, and moments resist ownership. They do not sit patiently for study. They arrive, influence, and disappear, leaving interpretation behind. This is unsettling because it suggests that some aspects of reality may always be underdetermined. We see the result, not the cause. We measure the effect, not the mechanism. And without mechanism, explanation remains provisional. Another recent realization deepens this sense of fragility. As datasets grow larger, astronomers are discovering that statistical confidence does not always correspond to conceptual clarity. A signal can be highly significant and still poorly understood. This is a dangerous combination. It creates certainty without comprehension. We know something happened. We don't know what it means. This flips the usual order of discovery. Historically, phenomena were observed repeatedly before being accepted as real. Now, computational power allows patterns to emerge from massive datasets quickly. Reality announces itself mathematically before it becomes intuitive. And intuition lags. This creates a gap between detection and understanding. Recent discoveries are filling that gap faster than we can close it. Another unsettling aspect is how many of these phenomena exist near thresholds. Thresholds of energy, thresholds of mass, thresholds of detectability. They appear precisely where systems transition between states, and transitions are inherently unstable. This suggests that much of the universe's interesting behavior may occur in regions we previously overlooked because they were difficult to study. We focused on stable systems because they were easier. Now that our instruments can probe instability, we are discovering that instability may be common, not exceptional. which reframes what we consider normal. Normal may not be equilibrium. Normal may be fluctuation, and fluctuation undermines prediction. Another recent discovery reinforces this idea. Astronomers studying the distribution of matter at intermediate scales noticed deviations that cannot be explained by simple models. Not large enough to demand new physics, too persistent to ignore. These deviations appear strongest where different cosmic structures interact, where filaments meet clusters, where voids press against density. These are boundaries, and boundaries behave differently than interiors. We are learning that the universe may be defined as much by its boundaries as by its contents. But boundaries are difficult. They are messy. They do not follow clean equations. They require case-by-case understanding, and that makes them unsettling. Because if boundaries dominate behavior, then universal laws become contextual. They apply differently depending on environment. This does not break physics, but it complicates it. And complication breeds uncertainty. Another quiet discomfort emerges from how recent discoveries interact with time. Not just when things happen, but how long they persist. Some phenomena appear stable on short timescales and unstable on long ones. Others appear chaotic briefly and then settle. This suggests that time itself may be a more active variable than we assume, not just a background parameter, but a factor that shapes behavior. If that's true, then our snapshots of the universe may be misleading. We may be catching systems and phases that don't represent their typical state, which means interpretation depends heavily on timing. Observe too early and you misclassify. Observe too late and you miss the event. This makes discovery precarious because it means understanding requires not just seeing, but seeing at the right moment. And the universe does not coordinate with our observation schedules. This leads to a deeper unease, that some truths may be temporarily inaccessible, not because they are hidden, but because they are fleeting. They exist briefly, influence outcomes, and then disappear, leaving only indirect traces that are ambiguous. This ambiguity is not a failure of method. It may be a feature of reality. Recent discoveries suggest that the universe may not prioritize permanence. It may prioritize process, and process does not linger for explanation. It simply unfolds. This challenges the comforting idea that everything important leaves a durable record. Some things may not. Some things may matter enormously and then vanish, leaving us to reconstruct their existence from subtle distortions. This reframes the emotional tone of recent discoveries. They are not terrifying because they imply chaos. They are unsettling because they imply incompleteness, not of knowledge alone, but of access. We may not be able to observe everything that matters, not because we lack technology, but because some phenomena are inherently transient, or conditional, or context-dependent. This realization introduces humility. It suggests that even with perfect instruments, understanding may be partial. Because reality may not be fully recordable, this doesn't diminish science. It reframes it. Science becomes an ongoing negotiation with what can be known, rather than a march toward total clarity. Recent discoveries push us toward that view. They show us a universe that is cooperative enough to reveal patterns, but indifferent enough to withhold closure. And that balance is deeply unsettling, because it means there may always be more happening than we can capture, more processes unfolding than we can model, more transitions than we can observe. And the more sensitive our instruments become, the more this imbalance reveals itself. We see more, but understand proportionally less. Not because we are failing, but because complexity grows faster than comprehension. But whether discovery itself has limits, we are only now beginning to notice. At some point, accumulation stops feeling like progress and starts feeling like pressure. Not the pressure of urgency, the pressure of implication. Recent discoveries are doing something subtle to astronomy. They are not overturning theories. They are not demanding revolutions. They are quietly forcing a reevaluation of expectations. and expectations are more fragile than we like to admit. For a long time, the underlying promise of science felt clear, that with better tools, clearer models, and enough time, the universe would slowly become more intelligible. Not necessarily simpler, but legible. Recent findings suggest that legibility itself may be conditional, not guaranteed. One of the most unsettling realizations to emerge over the past months is how often new observations forced scientists to say a particular phrase. We don't know if this is representative. That phrase matters because it acknowledges a gap, not just in explanation, but in context. When something is discovered, we instinctively ask whether it is common or rare, whether it reflects a general rule or an exception. But recent discoveries increasingly resist that classification. Some phenomena may be widespread, but faint. Others may be intense, but fleeting. Some may only occur under very specific conditions. This makes representativeness difficult to establish. And without representativeness, prediction weakens. Another unsettling pattern is emerging from the way discoveries cluster around certain regions of parameter space. Mass thresholds, energy limits, density boundaries. The universe seems particularly active near these boundaries. Not explosive, but expressive, as if transitions themselves are fertile ground for complexity. This challenges a long-standing assumption that stability is the norm and instability is rare. Recent discoveries suggest the opposite may be true, that much of the universe's interesting behavior occurs during transitions, moments when systems are neither fully formed nor fully dissolved. These moments are short-lived, hard to capture, and deeply informative, but they resist prolonged study. This creates a strange imbalance. The most revealing phenomena may be the least observable, and the most observable phenomena may be the least representative. That inversion is unsettling, because it means our understanding may be biased toward what lasts, not what matters. Another quiet discomfort arises from how often recent findings rely on inference chains that are long and delicate. A slight shift in one assumption changes the conclusion dramatically. This sensitivity suggests that our models may be finely tuned to limited regimes. They work extremely well within familiar boundaries, but become fragile near extremes. And the universe seems to spend a lot of time near extremes. This fragility doesn't invalidate the models. It contextualizes them. They are tools, not mirrors. And tools have ranges. Using them outside those ranges produces distortion. Recent discoveries may be revealing where those ranges end. Another unsettling realization concerns feedback. We often imagine cosmic processes as linear. Cause produces leads to effect. But recent observations increasingly suggest feedback loops, processes that influence themselves, outflows that reshape environments that later influence new outflows, energy that alters structure that later alters energy distribution. These loops introduce non-linearity. Non-linearity undermines intuition because outcomes become sensitive to initial conditions. Small differences amplify, and amplification creates diversity. This may explain why the universe appears increasingly strange as we look closer, not because it is disorderly, but because it is responsive. Responsive systems produce variation. Variation resists categorization, and categorization is how we feel secure. Another recent line of discovery reinforces this discomfort. Astronomers have noticed that some cosmic systems appear to operate differently depending on their history, not just their current state. Two systems with similar present conditions can behave differently because of how they arrived there. This introduces path dependence, and path dependence means that understanding requires knowledge of history. But history is difficult to reconstruct, especially in a universe where signals fade, disperse, or are overwritten. This suggests that some aspects of cosmic behavior may be fundamentally underdetermined, not because information is hidden, but because it is lost, which raises a troubling implication that some questions may not have recoverable answers. not because they are meaningless, but because the universe does not preserve all records. We are accustomed to thinking of the universe as a perfect archive. Light travels vast distances unchanged. Radiation carries information across time. But recent discoveries suggest that information degrades, not completely, but enough to introduce ambiguity, which means that some past states may only be partially reconstructible. This doesn't negate knowledge, it limits it. Another unsettling implication emerges from how these discoveries affect prediction. Cosmology has long been confident in predicting large-scale trends: the expansion of the universe, the formation of structure, the evolution of stars. These predictions remain robust. But recent findings suggest that small-scale variability may propagate upward. Local irregularities may influence global outcomes more than expected. If that's true, then the future may be less determined than models suggest. Not chaotic, but flexible, which undermines a comforting narrative that the universe unfolds along a fixed trajectory. Instead, it may explore a range of possible futures. This possibility is not frightening in itself. What's unsettling is how difficult it becomes to distinguish inevitability from contingency. Which events had to happen? Which could have gone differently? Recent discoveries blur that distinction. They show us systems that behave differently under nearly identical conditions. They show us outcomes that depend on subtle, perhaps unmeasurable factors. This challenges the idea that complete prediction is possible, even in principle, and that realization shifts the emotional tone of discovery. Science becomes less about uncovering certainty and more about navigating possibility. Possibility is exciting, but it is also destabilizing because it lacks closure. Another discomfort arises from how recent discoveries interact with explanation itself. Some phenomena may not admit simple explanations, not because they are mysterious, but because they emerge from complex interactions that cannot be reduced easily. This doesn't mean they are beyond understanding. It means understanding may require accepting irreducibility, that some behaviors cannot be decomposed into simpler components without losing meaning. This is unsettling because it contradicts a deep scientific instinct that complexity can always be broken down. Recent discoveries suggest that some complexity may be fundamental, not emergent, and fundamental complexity is harder to accept because it limits simplification. Another realization quietly emerges. As instruments improve, the universe does not appear to become quieter. It becomes busier, more signals, more variation, more exceptions. This suggests that the universe may not be sparse. It may be dense with phenomena, many of which we are only beginning to glimpse. And density increases cognitive load. It becomes harder to maintain coherent narratives, harder to tell clean stories, which brings us to the most unsettling implication of all, that the universe may not be narratively friendly. It does not organize itself into clean arcs with clear beginnings and ends. It produces overlapping processes, simultaneous events, competing influences, and our desire for simple explanations may be a human projection. Recent discoveries are confronting us with that possibility, not aggressively, quietly. They don't shout that we are wrong. They simply refuse to fit neatly. And refusal is powerful because it forces adaptation. This does not mean science is failing. It means it is maturing, moving from confidence to caution, from certainty to humility, from expectation to attention. And attention is demanding. It requires patience. It requires acceptance of ambiguity. It requires the willingness to say, "We don't know yet," without treating that as defeat. Recent discoveries invite us into that space, a space where understanding is provisional, where models are useful but incomplete, where observation is powerful but limited, where the universe is neither hostile nor accommodating. It simply exists. And that existence does not guarantee clarity. This realization is quietly terrifying, not because it threatens us, but because it challenges our assumptions about knowing. It suggests that the universe may always retain some autonomy from explanation, that some aspects of reality may resist full capture, not because they are hidden, but because they are complex, transient, contextual, or irreducible. And that resistance may be permanent, from what exists to how we respond to uncertainty itself. There is a subtle emotional shift that happens when uncertainty stops feeling temporary. At first, not knowing feels like a problem to be solved, a gap to be filled, a question waiting for the right answer. But when uncertainty persists, when it deepens instead of shrinking, it begins to change how we relate to knowledge itself. Recent discoveries are doing precisely that. They are not just adding unanswered questions. They are reshaping the way scientists think about answers. For a long time, astronomy operated under an unspoken confidence that ignorance was local and temporary. We don't know this yet. We'll figure it out soon. Better instruments will resolve it. That confidence was justified. It worked. Again and again, better data dissolved mystery. But the current wave of discoveries feels different, not because they are unsolvable, but because solving them does not necessarily restore certainty. It often replaces one discomfort with another, a deeper one. Consider how astronomers respond to recent anomalies. They don't rush to declare new physics. They don't abandon established frameworks. Instead, they pause. They reanalyze. They widen error bars. They speak more cautiously. This caution is not weakness. It is adaptation. Because recent discoveries suggest that the universe may not reward premature certainty. Instead, it rewards patience. But patience comes at a psychological cost. It requires accepting that some questions may remain open longer than expected, and that openness can feel destabilizing. Another subtle shift is happening alongside this. Astronomers are becoming more comfortable discussing uncertainty publicly, not just as a caveat, but as a feature. Phrases like, "we don't yet understand," and "this may point to unknown processes," appear more frequently in scientific communication. This transparency is healthy, but it also signals something deeper, a recognition that uncertainty is not merely a temporary inconvenience. It may be a persistent condition. Recent discoveries encourage this recognition. They show that understanding is not simply cumulative, it is conditional, dependent on perspective, dependent on scale, dependent on context. And context is harder to control than data. This realization changes how discoveries feel emotionally. Instead of triumph, there is restraint. Instead of closure, there is hesitation. Instead of finality, there is provisional confidence. This is not pessimism, it is realism. And realism can be unsettling because it forces us to confront a possibility we rarely articulate, that some aspects of the universe may never align perfectly with our frameworks, not because they are beyond reason, but because reason itself operates within limits. This idea is uncomfortable. It pushes against a deeply ingrained narrative that science, given enough time, will explain everything. Recent discoveries don't deny that possibility outright. They complicate it. They suggest that explanation may be asymptotic, approaching clarity without fully reaching it. And asymptotes are frustrating. They promise progress without completion. Another recent pattern reinforces this discomfort. As data sets grow larger, scientists are finding more exceptions, not fewer. This contradicts an intuitive expectation that more data should smooth out irregularities. But instead, more data reveals structure within irregularity, patterns within noise, complexity within what once looked simple. This suggests that simplicity may have been an artifact of ignorance. We didn't see complexity because we couldn't resolve it. Now we can. And the result is not reassurance. It is intricacy. This intricacy forces a shift in mindset, from solving puzzles to managing ambiguity, from seeking final answers to refining models, from certainty to probability. This shift is intellectually healthy, but emotionally it is demanding, because humans crave closure. We are uncomfortable with open-endedness. Recent discoveries deny us closure. They leave questions hanging, not indefinitely, but persistently. Another unsettling aspect is how these discoveries affect narrative. Science often communicates through stories, origins, evolutions, futures. These narratives provide coherence, but recent findings resist clean storytelling. They introduce branching paths, alternate histories, contingent outcomes. The universe begins to look less like a story with a plot, and more like a landscape with many routes. This undermines a comforting illusion that reality unfolds according to a script. Instead, it unfolds according to conditions, and conditions vary. This realization subtly shifts responsibility. If outcomes are conditional, then understanding requires acknowledging context, not just laws. This complicates explanation, because context is messy. It doesn't compress neatly into equations. Another psychological shift emerges from how scientists talk about prediction. Historically, prediction was a marker of understanding. If you can predict behavior, you understand the system. Recent discoveries complicate this. Some systems are understood in principle, but unpredictable in practice. Not chaotic, but sensitive. Small uncertainties amplify. This limits prediction even when laws are known. This is unsettling because it separates understanding from control. We may understand how something works and still be unable to predict what it will do next. This challenges a deep association. That knowledge grants mastery. Recent discoveries weaken that association. They suggest that knowledge grants insight, not dominance. Insight without dominance can feel incomplete, but it may be more honest. Another shift concerns humility, not as a moral value, but as an epistemic stance. Recent discoveries encourage humility, not because we failed, but because the universe is complex enough to warrant it. Humility becomes adaptive. It prevents overreach. It slows interpretation. It encourages listening to data rather than forcing conclusions. But humility also means accepting limits, and limits are uncomfortable. They remind us that understanding is bounded, that perspective matters, that frameworks are tools, not truths. This realization changes how recent discoveries feel. They don't inspire fear of the unknown. They inspire awareness of limitation. And awareness of limitation can feel like vulnerability because it exposes the boundaries of competence, not just of individuals, but of humanity as a whole. This is where the emotional weight accumulates, not because the universe is hostile, but because it is indifferent. It does not care whether we understand it. It does not simplify itself for our benefit. It behaves according to conditions that may not align with human preference. Recognizing this can feel destabilizing because it strips away a subtle comfort that the universe is ultimately knowable in a clean, satisfying way. Recent discoveries don't disprove knowability. They complicate it. They suggest that knowing may be partial, incremental, contextual, and that some uncertainty may be permanent. This does not diminish science. It reframes its purpose, from conquering ignorance to navigating complexity. This reframing is intellectually mature, but emotionally challenging. Because navigation lacks finality, there is no endpoint, only continued adjustment. Recent discoveries push us toward this mindset. They invite us to replace certainty with attentiveness, to value careful observation over confident declaration, to accept that understanding evolves, not toward perfection, but toward nuance. This shift has consequences beyond astronomy. It changes how we think about knowledge itself. It challenges the idea that progress eliminates mystery. Instead, progress may deepen it by revealing layers of complexity that were previously invisible. This is not regression. It is refinement. But refinement requires patience, and patience requires tolerance for ambiguity. Recent discoveries are testing that tolerance. They ask whether we can accept a universe that does not resolve cleanly, that offers insight without closure, that rewards curiosity without guaranteeing satisfaction. And that may be the most unsettling implication of all. Not that the universe is unknowable, but that knowing may always remain unfinished. As uncertainty becomes more familiar, something else begins to change as well: the way questions are asked. For a long time, scientific questions were framed with an expectation of resolution. What is this made of? Where did it come from? How does it work? These questions imply answers that are stable, definable, and final. Recent discoveries are quietly reshaping that expectation. Instead of asking what something is, scientists increasingly ask how it behaves under different conditions. Instead of asking where it came from, they ask when it changes character. Instead of asking why in absolute terms, they ask under what constraints. This shift matters. It signals a movement away from static understanding toward conditional understanding. And conditional understanding is less comforting because it admits variability. It suggests that answers may depend on context in ways that cannot be simplified. Recent discoveries encourage this reframing because they resist singular explanations. They demand families of explanations, ranges of behavior, parameter spaces rather than points. This changes how discovery feels. Instead of uncovering a fact, scientists map a possibility, and possibility is inherently open-ended. Another subtle change is happening alongside this. The recognition that absence of evidence is not evidence of absence is becoming more operational, not just philosophical. In practical terms, astronomers are realizing that non-detections matter, not as null results, but as constraints that shape interpretation. Recent discoveries show that what we don't see can be just as informative as what we do. But interpreting absence requires caution, because absence may reflect limitation rather than non-existence. This creates a tension. We must act on incomplete information while acknowledging its incompleteness. This tension is uncomfortable, but it is becoming unavoidable. Another shift emerges in how scientists think about anomalies. Anomalies were once treated as warnings, signs of error, problems to be eliminated. Now, anomalies are increasingly treated as signals, not necessarily of new physics, but of unexplored regimes. Recent discoveries show that anomalies often arise where coverage is sparse, where resolution drops, where assumptions are stretched. This reframes anomalies as invitations rather than threats. But invitations carry responsibility. They demand careful engagement, and careful engagement is slow. In an era of rapid data accumulation, slowness feels counterintuitive, but recent discoveries reward slowness. They punish haste. Premature conclusions collapse under scrutiny. Cautious interpretation survives. This is changing scientific culture in subtle ways. There is less appetite for sweeping claims, more emphasis on robustness, more patience for ambiguity. This is intellectually healthy, but emotionally it can feel unsatisfying because ambiguity does not provide narrative closure. It offers continued attention. Another emerging realization is how much interpretation depends on models. Models are not reality. They are compressions. They simplify complexity into manageable forms. Recent discoveries expose the limits of these compressions. They reveal behaviors that exist outside model assumptions, not because the models are wrong, but because they were never designed to capture everything. This creates a delicate situation. Models must be expanded, but expansion increases complexity. Complexity reduces interpretability. This trade-off is unavoidable, and it reshapes expectations. Instead of hoping for a single elegant model, scientists increasingly accept a patchwork. Multiple models, each valid in specific regimes. This patchwork approach is pragmatic, but it challenges a deep aesthetic preference that nature is fundamentally simple. Recent discoveries do not deny simplicity entirely. They localize it. Simplicity exists within domains, but the universe may not be globally simple. It may be locally coherent and globally complex. This realization alters the emotional relationship with discovery. Instead of awe rooted in order, there is awe rooted in richness. Richness is harder to summarize, harder to teach, harder to conclude. But it may be closer to reality. Another quiet shift is happening in how scientists think about explanation. explanation used to mean reduction, breaking phenomena into smaller parts. Recent discoveries suggest that reduction alone may be insufficient. Some behaviors emerge only at scale. They cannot be inferred from components alone. This is not a rejection of reductionism. It is an acknowledgement of emergence. Emergence introduces irreducibility, and irreducibility limits explanation. Not absolutely, but practically. This challenges a long-held confidence that given enough detail, everything becomes clear. Recent discoveries suggest that clarity may be distributed. No single perspective captures the whole. Understanding may require synthesis rather than decomposition. Synthesis is harder. It requires holding multiple views simultaneously, and humans are not naturally good at that. This introduces cognitive strain, which contributes to the unsettling feeling surrounding recent discoveries. They are not difficult because they are obscure. They are difficult because they demand new ways of thinking. Another change concerns the role of surprise. Surprise used to signal error. Now, surprise often signals discovery, but frequent surprise recalibrates expectation. If everything surprises us, surprise loses meaning. Recent discoveries are pushing us toward a different metric, not surprise, but consistency across uncertainty. We begin to value results that remain stable under different assumptions. This shifts the goal from finding shocking anomalies to building resilient interpretations. This is a mature approach, but it lacks drama, which creates tension between public expectation and scientific reality. The public often wants revelations. Science increasingly offers nuance. Recent discoveries widen this gap. They are unsettling partly because they resist simplification. They do not compress easily into headlines. They require time, attention, patience. This creates a mismatch between how discovery feels to scientists and how it is perceived externally. That mismatch can amplify discomfort because it pressures scientists to communicate uncertainty clearly without diminishing significance. This is difficult. Another subtle implication emerges. As discoveries become more conditional, certainty becomes distributed. No single paper settles a question. Understanding emerges across many studies. Over time, this slows resolution, but increases reliability. This trade-off is rational, but emotionally challenging because it denies the satisfaction of closure. Recent discoveries demand acceptance of this slower pace. They resist immediate synthesis. They insist on accumulation. This insistence changes how progress is perceived. Progress becomes less about breakthroughs and more about convergence. Convergence is quiet. It lacks spectacle, but it is durable. Recent discoveries are pushing science toward this quieter mode, which contributes to their unsettling tone. They do not feel triumphant. They feel unresolved. Another shift concerns trust. Not trust in data, but trust in interpretation. Scientists are increasingly explicit about the provisional nature of conclusions. This transparency is good, but it also exposes uncertainty more visibly. Uncertainty that was always present, but often implicit. Now it is explicit. This can feel destabilizing because it removes a buffer. The buffer of assumed certainty. Recent discoveries remove that buffer. They force confrontation with limits, not as failures, but as realities. This reframes expertise. Expertise becomes less about having answers and more about navigating uncertainty responsibly. This is a profound shift. It changes the social role of science, from authority to guide, from source of truth to interpreter of evidence. This shift is unsettling because it changes expectations. People want answers. Science increasingly offers probabilities. This mismatch creates discomfort, but it may be unavoidable because recent discoveries suggest that probability is the natural language of reality, not certainty. Another implication emerges from this. If understanding is probabilistic, then disagreement becomes expected. Different interpretations can coexist, not because someone is wrong, but because evidence underdetermines conclusion. This pluralism is intellectually healthy, but emotionally challenging because it denies finality. Recent discoveries normalize this condition. They make disagreement a feature, not a bug. This reframes scientific debate from competition to collaboration. But collaboration requires patience, and patience is demanding. This is where the unsettling feeling deepens, not because the universe is threatening, but because understanding is demanding. It asks more of us, more restraint, more tolerance for ambiguity, more willingness to revise. Recent discoveries are forcing this growth. They are stretching not just models, but minds. And stretching is uncomfortable, yet necessary. As expectations shift, so do strategies. When uncertainty becomes a constant rather than a temporary obstacle, discovery itself begins to change shape. Scientists no longer assume that better instruments will automatically produce clearer answers. They assume answers will become more complex. Recent discoveries are accelerating this shift. Instead of building tools to confirm expectations, astronomers increasingly design tools to explore uncertainty. They widen parameter spaces. They observe across more wavelengths simultaneously. They prioritize flexibility over optimization. This change is subtle but profound. It signals an acceptance that the universe may not reward precision with simplicity. It may reward it with depth. Depth, however, comes with cost. Deeper observation means more data. More data means more anomalies. More anomalies mean more interpretive burden. This creates a new challenge. How do you distinguish meaningful patterns from the background of complexity? Recent discoveries show that this distinction is no longer straightforward. Patterns emerge that are statistically real, but conceptually ambiguous. They exist, but they don't immediately explain themselves. This forces a reconsideration of what discovery means. Is discovery the moment something is detected, or the moment it is understood? Recent findings suggest those moments may be drifting apart. Detection comes first. Understanding lags, sometimes by years, sometimes indefinitely. This temporal gap is unsettling because it means knowledge accumulates faster than comprehension. And when comprehension lags, confidence erodes. Another strategic shift follows from this. Scientists are becoming more conservative in their claims, not because they lack courage, but because recent discoveries punish overinterpretation. Claims that reach too far collapse under scrutiny. Claims that remain narrow endure. This leads to a culture of restraint. Restraint is intellectually responsible, but emotionally unsatisfying. It denies the dramatic arc of revelation. Recent discoveries don't offer epiphanies. They offer persistence. This persistence forces a new kind of patience, a patience that accepts that some questions may not converge quickly, or at all. Another shift concerns collaboration. As discoveries become more complex, no single discipline suffices. Astrophysics blends with particle physics. Cosmology intersects with statistics. Observation requires computation at unprecedented scale. This interdisciplinarity is powerful, but it also diffuses authority. No one person sees the whole picture. Understanding becomes distributed. This distribution introduces fragility. Miscommunication can distort interpretation. Assumptions from one field may not translate cleanly to another. Recent discoveries expose these seams. They reveal how much interpretation depends on shared language, and how fragile that language can be. Another unsettling realization emerges. As tools become more sensitive, they begin to detect phenomena at the edge of what is practically observable, signals barely above noise, patterns barely distinguishable from randomness. At these edges, interpretation becomes probabilistic. Confidence intervals widen. Decisions become conditional. This is not failure, it is honesty. But honesty can feel unsettling because it removes certainty. Recent discoveries force scientists to live in that space, to operate without guarantees. Another strategic adjustment follows. Instead of seeking definitive explanations, researchers increasingly seek robustness. Does a conclusion hold under different assumptions? Does it survive changes in method? Does it persist across data sets? This emphasis on robustness prioritizes reliability over clarity. A robust but vague conclusion may be preferred to a clear but fragile one. This trade-off is rational, but emotionally, it feels incomplete. Recent discoveries encourage this trade-off. They punish clarity that lacks support. Another implication arises from how discoveries are communicated. As uncertainty becomes more explicit, communication must become more careful. Language shifts from "this is" to "this suggests," from "we know" to "evidence indicates," from "explains" to "is consistent with." This linguistic shift matters. It signals a change in epistemic posture. Knowledge is presented as tentative, contextual, subject to revision. This honesty is healthy, but it challenges expectations. The public often seeks certainty. Recent discoveries undermine certainty. This mismatch creates tension between what science can responsibly offer and what audiences desire. This tension contributes to the unsettling feeling, not because discoveries are dangerous, but because they destabilize narratives. Another strategic consequence involves prioritization. When anomalies multiply, not all can be pursued equally. Choices must be made. Which questions deserve attention? Which uncertainties matter most? Recent discoveries complicate these decisions because anomalies often resist ranking. Some are subtle but profound. Others are dramatic but localized. Determining significance becomes difficult. This difficulty introduces subjectivity, not arbitrary subjectivity, but value-laden judgment, and judgment introduces bias. Recent discoveries force acknowledgement of this bias. They reveal that science is not purely mechanical. It involves choice, attention, interpretation. This realization is unsettling because it undermines the myth of complete objectivity. Science strives for objectivity, but it is practiced by humans with limited time, limited resources, limited attention. Recent discoveries highlight this human element. They expose the scaffolding behind knowledge. Another shift concerns the future of explanation. As complexity grows, explanation may become layered, different explanations at different levels, none complete on their own. Understanding becomes composite. This composite understanding resists simplification. It cannot be reduced to a single narrative. This frustrates communication, but it may reflect reality more accurately. Recent discoveries push us toward this layered view. They show that no single lens captures the whole. Another unsettling implication emerges. If understanding is layered and conditional, then disagreement becomes normal. Different interpretations can coexist without contradiction. This pluralism is intellectually healthy, but socially challenging, because it complicates authority. Who decides which interpretation prevails? Oftentimes does. Evidence accumulates. Consensus emerges slowly. Recent discoveries demand this slow process. They resist quick resolution. This patience is necessary, but it feels uncomfortable because it delays closure. Another strategic change follows. Researchers increasingly emphasize process over result. They publish methods, share data, encourage replication. This transparency is vital, but it also exposes uncertainty. Methods reveal assumptions. Assumptions reveal limits. Recent discoveries benefit from this openness, but openness makes ambiguity visible, which can feel destabilizing. Another consequence involves prediction. As understanding becomes conditional, prediction becomes probabilistic. Forecasts include ranges. Scenarios replace certainties. This changes how future outcomes are discussed, not as inevitabilities, but as possibilities. This shift is unsettling because it undermines narrative finality. There is no single future. There are many. Recent discoveries encourage this mindset. They suggest that the universe explores possibility spaces, not fixed trajectories. This reframes cosmology from destiny to dynamics. Dynamics are harder to summarize, harder to conclude, but perhaps more accurate. Another strategic adaptation emerges. Scientists increasingly value falsifiability, not just in principle, but in practice. They seek tests that could prove ideas wrong. This humility is strengthened by recent discoveries, which show how easily interpretation can mislead. This emphasis on falsifiability slows progress, but increases trust. Trust becomes more important as certainty declines. Recent discoveries require trust. Trust in method, trust in transparency, trust in patience. This trust is demanding. It requires accepting that answers may be delayed, that understanding may be partial, that confidence must be earned gradually. This is not how we often imagine discovery. We imagine breakthroughs, moments of clarity. Recent discoveries offer something else. They offer sustained engagement, ongoing revision, incremental insight. This is intellectually mature, but emotionally taxing because it denies the comfort of final answers. Another unsettling realization follows. As complexity increases, specialization intensifies. No one understands everything. Knowledge fragments. This fragmentation requires coordination, which is difficult. Misalignment can produce misunderstanding. Recent discoveries expose this risk. They demand integration across domains. Integration is slow, but necessary. This necessity slows resolution further, which contributes to the unsettling tone. Another implication arises from scale. As discoveries span more scales simultaneously, from quantum to cosmic, integration becomes harder. Bridging scales requires assumptions. Assumptions introduce uncertainty. Recent discoveries stretch these bridges. They test their strength. Some hold, some strain. This strain is unsettling because it reveals the limits of coherence. Not everything fits neatly, and forcing fit produces distortion. Recent discoveries encourage acceptance of misfit, not as failure, but as reality. This acceptance marks a shift from seeking unity at all costs to tolerating plurality. Plurality is intellectually honest, but emotionally uncomfortable because it resists closure. This brings us to a deeper implication. The future of discovery may not be about eliminating mystery, it may be about managing it. Understanding may coexist with uncertainty, not temporarily, but permanently. Recent discoveries point in this direction. They show a universe that is not obligated to resolve itself cleanly, that reveals itself in fragments, that resists total capture. This does not diminish science. It deepens it. But depth requires endurance, and endurance is demanding. When uncertainty stops being an obstacle and becomes a condition, something fundamental shifts, not in the data, not in the equations, but in how we relate to the universe itself. For much of scientific history, uncertainty carried an implicit promise that it was temporary, that it marked a boundary we had not yet crossed. Recent discoveries weaken that promise. They suggest that uncertainty may not always retreat as knowledge advances. In some cases, it may deepen. This realization changes the emotional landscape of discovery. The universe begins to feel less like a puzzle with a final picture, and more like a terrain that never fully reveals itself. Exploration continues, but completion does not arrive. This is unsettling because it challenges a quiet expectation we rarely question. That understanding moves in one direction, from ignorance to clarity, from confusion to order. Recent discoveries suggest a different trajectory, from ignorance to partial clarity, to deeper complexity. And complexity does not feel like progress in the way clarity does. It feels heavier. One of the most profound consequences of this shift is how it alters our sense of position. We often imagine ourselves as observers standing outside the universe, studying it objectively. But recent discoveries blur that boundary. They show that our tools, our assumptions, and our perspectives shape what we see. We are not detached. We are embedded. And embedded observers do not get complete views. They get slices, angles, projections. This realization is unsettling because it undermines the idea of a privileged perspective. There may be no vantage point from which the universe becomes fully transparent. only perspectives, each revealing something, each hiding something else. Recent discoveries force us to confront this limitation, not dramatically, quietly. They do not shout that we are blind. They reveal that vision is conditional. Another implication emerges when we consider how meaning is constructed. We often seek meaning in coherence, patterns that align, structures that repeat, laws that apply universally. Recent discoveries complicate coherence. They show patterns that hold locally but fail globally, behaviors that emerge under specific conditions and vanish under others. This suggests that meaning may be contextual, not universal, and contextual meaning is fragile. It depends on framing. Change the frame, and interpretation shifts. This is unsettling because it denies a single, stable narrative. Instead, the universe offers many overlapping stories, none complete, none final. Another emotional consequence arises from how recent discoveries affect expectation. Expectation shapes comfort. We are comfortable when reality behaves roughly as anticipated. Recent discoveries disrupt expectation without offering replacement. They introduce novelty without reassurance. This creates a lingering unease, not fear, but disorientation, the sense that the ground beneath understanding is less solid than assumed. Another shift follows. As uncertainty persists, the desire for certainty intensifies. This is human, but recent discoveries resist satisfaction. They do not resolve cleanly. They accumulate. This creates a tension between desire and reality. The desire for closure meets a universe that does not provide it easily. Living with this tension requires adaptation, and adaptation is uncomfortable. Another subtle implication concerns humility. Not humility as modesty, but humility as alignment with reality. Recent discoveries encourage humility by revealing limits. Limits of prediction, limits of observation, limits of interpretation. Accepting these limits does not weaken science. It strengthens it, but it also requires relinquishing a comforting illusion that science can, in principle, explain everything completely. Recent discoveries suggest that explanation may always be partial, provisional, context-dependent. This does not mean the universe is unknowable. It means knowing is layered, and layers imply depth. Depth implies obscurity. This depth alters how we experience discovery. Instead of triumph, there is respect. Instead of mastery, there is engagement. Instead of domination, there is coexistence. This shift may be the most unsettling of all, because it repositions humanity, not as conquerors of knowledge, but as participants in an unfolding process. Participants who can observe, infer, and model, but not fully command. Another implication emerges when we consider time. Not cosmic time, but human time. Recent discoveries unfold slowly. They require years of observation, decades of analysis, generations of refinement. This slowness contrasts sharply with cultural expectations of rapid resolution. The mismatch creates friction. Science moves at the pace of evidence. Culture moves at the pace of attention. Recent discoveries strain this relationship. They demand patience in a world that rewards immediacy. This tension contributes to the unsettling feeling, not because discoveries are threatening, but because they resist consumption. They cannot be easily summarized. They cannot be quickly resolved. They linger. Another emotional consequence arises from how uncertainty reshapes curiosity. Curiosity is often fueled by the promise of answers. When answers remain elusive, curiosity changes. It becomes less about solving and more about witnessing. This shift alters motivation. Instead of asking, "What is this?" we ask, "How does this behave?" Instead of seeking conclusions, we seek patterns. This reframing is subtle, but profound. It transforms science from a quest for endpoints into a practice of attention. Attention is demanding. It requires sustained focus. It offers no guarantee of reward. Recent discoveries push us toward this mode. They reward those willing to observe without immediate resolution. This is unsettling because it denies the dopamine of closure, but it may be more honest. Another implication follows. As understanding becomes provisional, belief must adjust. Not belief in science, but belief about what science offers. It offers insight, not certainty, guidance, not guarantees. This reframing challenges how we trust knowledge. Trust becomes conditional, not blind, not absolute. This conditional trust is mature, but uncomfortable, because it requires constant reevaluation. Recent discoveries encourage this stance. They demand vigilance. Another subtle consequence emerges. When uncertainty persists, imagination fills the gaps. This is natural, but imagination can mislead. Recent discoveries require discipline. They require resisting speculation beyond evidence. This restraint is difficult because uncertainty invites stories. Recent discoveries resist storytelling. They resist anthropocentric narratives. They resist dramatization. They remain quiet. This quietness is unsettling in a culture accustomed to spectacle, but it may be appropriate because the universe does not perform for us. It exists. Another implication emerges when we consider meaning itself. Meaning often arises from coherence and purpose. Recent discoveries suggest that coherence may be local, not global. Purpose may be projected, not inherent. This realization does not negate meaning, but it relocates it. Meaning becomes something we construct, not something we uncover. This is unsettling because it removes an external anchor, but it also grants agency. We choose how to relate to uncertainty. Another emotional shift follows. As certainty fades, wonder deepens. Not wonder rooted in amazement, but wonder rooted in humility. The recognition that reality exceeds our grasp, that there is always more than we can see, more than we can explain. This wonder is quieter than awe, but more enduring. Recent discoveries cultivate this kind of wonder. They do not overwhelm. They invite contemplation. This invitation is unsettling because it lacks resolution, but it may be the most honest response. Another implication concerns the future. If uncertainty is permanent, what motivates continued exploration? Recent discoveries suggest the answer is not closure. It is understanding within limits, progress without finality. This is a different vision of science, not a ladder to ultimate truth, but a map that grows richer without becoming complete. This vision is unsettling, but it is also sustainable. It accepts reality as open-ended, and openness invites engagement. Another subtle consequence emerges. As uncertainty becomes normalized, fear diminishes. Not fear of the unknown, but fear of being wrong. Being wrong becomes expected. Revision becomes routine. This resilience strengthens science, but it also normalizes ambiguity. Living with ambiguity requires emotional maturity. Recent discoveries demand this maturity. They test our tolerance for not knowing. They test our patience. They test our willingness to remain curious without certainty. This testing is not malicious. It is a byproduct of complexity, and complexity is not a problem to be solved. It is a condition to be navigated. This brings us to the quiet heart of why recent discoveries feel terrifying. Not because they threaten safety, not because they imply danger, but because they challenge a deeply held comfort. That reality will eventually make sense in a complete, satisfying way. Recent discoveries suggest that may not happen. Understanding may always trail reality, by design, by necessity. This does not diminish our place in the universe. It clarifies it. We are observers within a system that exceeds us, capable of insight, capable of progress, but not of final capture. And that realization is unsettling because it demands humility. It demands patience. It demands acceptance of incompleteness. But it also offers something rare, a relationship with the universe based not on dominance, but on dialogue. A dialogue where questions persist, where answers evolve, where mystery remains, not as an enemy, but as a companion. When uncertainty becomes familiar, the question is no longer whether we can eliminate it. The question becomes how we live with it. Recent discoveries don't just change what we know about the universe. They change how the universe feels. Not distant and mechanical, not hostile or dramatic, but vast, subtle, and indifferent in a way that resists human expectation. For a long time, science offered a particular kind of comfort. Even when answers were missing, there was a sense that they existed somewhere ahead, waiting to be found. Recent discoveries weaken that sense. They suggest that some questions may not resolve cleanly, not because of ignorance, but because reality itself is layered in ways that resist compression. This realization doesn't arrive suddenly. It settles in slowly. At first, it appears as caution in language, then as hesitation in interpretation. Eventually, it becomes an undercurrent in how discovery is framed. The universe stops feeling like a problem to be solved. It begins to feel like a presence to be encountered. This shift is subtle but profound. It reframes curiosity. Curiosity is no longer driven solely by the promise of answers. It is driven by the desire to witness, to understand partially, to map without mastering. This kind of curiosity is quieter. It does not demand resolution. It tolerates ambiguity. Recent discoveries encourage this form of curiosity because they do not reward impatience. They punish it. Premature conclusions collapse. Overconfident narratives fracture. What survives is careful attention. Another consequence of this shift is a reevaluation of progress. Progress is often imagined as accumulation, more data, more precision, more certainty. But recent discoveries suggest a different model. Progress as refinement. Understanding becomes more nuanced, not more absolute. Certainty narrows even as insight deepens. This feels counterintuitive. We expect knowledge to reduce uncertainty. Instead, knowledge reveals the structure of uncertainty. This revelation is unsettling because it removes a comforting illusion that ignorance is a temporary state. Recent discoveries suggest that some forms of ignorance may be permanent, not because we lack tools, but because reality itself does not present clean answers. This does not imply futility. It implies limits, and limits force reflection. Another subtle shift emerges in how meaning is constructed. Meaning is often derived from coherence. When facts align, meaning feels stable. Recent discoveries disrupt alignment. They introduce misfit, phenomena that do not align neatly with existing frameworks. This misfit creates tension, and tension demands response. One response is denial. Another is overinterpretation. But the most productive response is acceptance. Acceptance that coherence may be local, not global. That meaning may emerge from patterns, not from total explanations. This acceptance changes the emotional tone of discovery. Instead of triumph, there is attentiveness. Instead of closure, there is continuity. This continuity is unsettling because it lacks an endpoint, but it may be more faithful to reality. Another consequence of recent discoveries is a reevaluation of scale. We often think in terms of the largest structures, galaxies, clusters, the observable universe. But many unsettling discoveries occur at intermediate scales, where systems interact, where boundaries blur, where categories overlap. These scales are messy. They resist simplification. They are neither fundamental nor emergent in a clean sense. They are transitional, and transitions are inherently unstable. Recent discoveries suggest that much of the universe's richness exists in these transitional regimes, not at extremes, but in between. This is unsettling because it challenges a preference for extremes. We are drawn to the biggest, the smallest, the most energetic. But the universe may be most expressive in the middle, where processes overlap, where influence is indirect, where outcomes are contingent. Another emotional shift follows from this realization. The sense of control diminishes. Not control over the universe that was always illusory, but control over understanding. We become aware that understanding is negotiated, not claimed. That interpretation is provisional. That revision is inevitable. This awareness can feel destabilizing, but it also fosters resilience because it prepares us for change. Another implication emerges when we consider how humans relate to mystery. Mystery is often treated as a problem, something to be eliminated. Recent discoveries suggest a different relationship: mystery as a condition, something that accompanies understanding rather than obstructs it. This reframing alters motivation. We are no longer driven solely by the desire to remove mystery. We are driven by the desire to coexist with it productively. This is unsettling because it denies finality, but it may be the only sustainable posture. Another shift concerns expectation. We often expect the universe to conform to elegance, simple laws, clean symmetries, unified explanations. Recent discoveries do not deny elegance. They complicate it. Elegance may exist at certain levels, but not universally. Reality may be elegant in principle and messy in practice. This duality is unsettling because it resists aesthetic satisfaction, but it may be accurate. Another implication emerges when we consider communication. How do we talk about a universe that resists simplification? How do we convey insight without overstating certainty? Recent discoveries force careful language that acknowledges ambiguity without undermining credibility. This balance is difficult. Too much certainty misleads. Too much uncertainty discourages. Navigating this balance is emotionally taxing, but necessary. Another subtle consequence is how recent discoveries affect trust. Trust in science is often linked to confidence, but confidence without humility can mislead. Recent discoveries encourage trust rooted in transparency, trust that admits uncertainty, trust that evolves. This kind of trust is more resilient, but it requires maturity. Another emotional shift follows. As certainty fades, fear often increases. But recent discoveries produce a different response. Not fear of catastrophe, but unease rooted in unfamiliarity. The universe feels less predictable, less obliging, but not threatening. This kind of unease is quieter. It lingers. It does not demand immediate action. It invites reflection. Another implication arises when we consider identity. Human identity has long been shaped by our understanding of the cosmos, from central to peripheral, from unique to ordinary. Recent discoveries add another layer, from knowing to questioning. Our identity shifts from knowers to learners, from masters to participants. This shift is unsettling because it reduces perceived authority, but it increases authenticity. Another consequence concerns ethics, not ethics in a moral sense, but epistemic ethics, how responsibly we claim knowledge. Recent discoveries demand restraint. They reward caution. They punish exaggeration. This encourages a culture of responsibility. But responsibility is heavy. It slows communication. It complicates narratives. Another implication emerges when we consider the future. If uncertainty is permanent, what does progress look like? Recent discoveries suggest progress that may be measured not by answers, but by better questions. Questions that are more precise, more contextual, more aware of limits. This reframes ambition. Ambition shifts from solving everything to understanding something well. This is less dramatic, but more realistic. Another emotional shift follows. As ambition becomes more focused, disappointment diminishes. We stop expecting finality. We stop demanding closure. We accept continuation. This acceptance is unsettling at first, but eventually stabilizing because it aligns expectation with reality. Another implication emerges. Living with uncertainty may foster curiosity that is less anxious, less desperate for resolution, more open-ended. This curiosity is sustainable. It does not burn out. Recent discoveries may be cultivating this form of curiosity, not by design, but by necessity. Another subtle realization follows. The universe does not reward arrogance. It does not punish humility. It simply responds to attention. Careful attention reveals nuance. Impatient attention reveals noise. Recent discoveries reward those willing to attend carefully. This is unsettling because it demands effort without guarantee, but it is also empowering because it places agency in method, not conclusion. Another implication concerns narrative again. The grand narrative of science as a march towards certainty may need revision. A more accurate narrative may be one of dialogue between observer and observed, between model and reality, between expectation and surprise. Dialogue does not end, it evolves. This evolution is unsettling because it resists final statements, but it is also honest. Another emotional shift emerges. As mystery persists, wonder deepens. Not the wonder of spectacle, but the wonder of complexity, of layered behavior, of subtlety. This wonder is quieter, but it endures. Recent discoveries cultivate this wonder. They do not overwhelm. They invite sustained engagement. This engagement changes the relationship between humans and the universe. We stop demanding answers. We start asking better questions. This is unsettling because it changes power dynamics, but it is also enriching. Another implication emerges. If understanding is always partial, then meaning is constructed collaboratively between data and interpretation, between observation and context, between science and philosophy. Recent discoveries blur disciplinary boundaries. They invite integration. This integration is difficult, but rewarding. Another emotional shift follows. As boundaries blur, certainty dissolves, but curiosity strengthens. We become more attentive, more careful, more patient. This patience is unsettling in a culture of immediacy, but it may be necessary. Another implication emerges when we consider silence. The universe is mostly silent. Recent discoveries often emerge from silence, from absence, from faint signals. This silence is not empty. It is full of subtlety. Learning to listen to silence requires adjustment. Recent discoveries force this adjustment. They teach us to attend to what is barely there. This attentiveness is unsettling because it demands focus without reward. But it is also profound because it reveals layers previously unseen. Another realization follows. The universe may not care whether we understand it, but it responds to how we observe it. Careful observation yields depth. Careless observation yields confusion. Recent discoveries highlight this difference. They reward rigor. They punish haste. This lesson is unsettling because it demands discipline, but it is also empowering because it places progress within reach. Another implication emerges. Living with a quietly terrifying universe may not mean fear. It may mean respect. Respect for complexity. Respect for limits. Respect for uncertainty. This respect changes behavior. It fosters patience. It encourages humility. It deepens curiosity. Recent discoveries cultivate this respect, not intentionally, but inevitably. This brings us to a final realization for this section. The universe is not obligated to reassure us. It is not obligated to make sense quickly. It exists on its own terms. Recent discoveries remind us of this. They do not threaten us. They unsettle us. And unsettling is not the same as harmful. Unsettling invites growth. It demands adaptation. It challenges assumptions. And in doing so, it expands understanding, not toward certainty, but toward depth. There's a difference between fear and unease. Fear demands action. Unease demands attention. Recent discoveries do not provoke panic. They provoke unease. And unease lingers longer than fear because it does not resolve through reaction. It settles into thought. As the picture of the universe grows more complex, the emotional response shifts. The universe no longer feels like a machine running behind a locked door. It feels like a system that allows observation but resists simplification. This resistance is not hostility, it is indifference. And indifference is more unsettling than threat. A threat implies intention. Indifference implies autonomy. Recent discoveries emphasize this autonomy. The universe does not behave for us. It behaves according to conditions that may not align with human intuition. This realization slowly alters how we interpret discovery. We stop asking whether the universe makes sense. We start asking whether our expectations do. This inversion is subtle, but powerful. It shifts responsibility, not to change the universe, but to change perspective. Another emotional consequence emerges. As uncertainty becomes normalized, anxiety about not knowing diminishes, not because uncertainty disappears, but because it becomes familiar. This familiarity does not remove discomfort. It transforms it. Unease becomes background rather than crisis. This background unease is cognitively demanding. It requires sustained awareness, but it also fosters resilience. We adapt to ambiguity. We learn to operate without closure. Recent discoveries encourage this adaptation. They make ambiguity unavoidable. Another implication arises when we consider time again. Not cosmic time, but the time horizon of understanding. Some questions may take decades. Others may never resolve. This does not paralyze inquiry. It redirects it. Scientists become comfortable working on problems whose outcomes are uncertain. This comfort with uncertainty is a learned skill. Recent discoveries accelerate its development. Another subtle shift occurs in how success is defined. Success is no longer equated solely with answers. It includes better framing of questions, clearer articulation of uncertainty, more precise delineation of limits. This redefinition of success is unsettling because it lacks finality, but it is sustainable. It prevents burnout. It allows progress without illusion. Another emotional consequence concerns trust again. Trust shifts from certainty to process. We trust methods. We trust transparency. We trust the willingness to revise. This trust is more robust than trust in answers, because answers change, process endures. Recent discoveries reinforce this distinction. They show that answers are provisional, but methods persist. Another implication emerges when we consider communication beyond science. Public discourse often demands certainty, clear statements, definitive conclusions. Recent discoveries resist this demand. They force communicators to explain uncertainty without undermining credibility. This is difficult because uncertainty is often misinterpreted as weakness. But recent discoveries demonstrate the opposite. Acknowledging uncertainty is strength. It signals alignment with reality. This alignment is unsettling because it contradicts cultural narratives of mastery, but it is honest. Another emotional shift follows. As mastery recedes, curiosity matures. Curiosity becomes less about conquering the unknown, more about engaging with it. This engagement is quieter, less dramatic, but deeper. Recent discoveries cultivate this form of curiosity. They reward sustained attention rather than excitement. Another implication arises. As curiosity matures, impatience becomes counterproductive. Quick conclusions fail. Slow synthesis succeeds. This favors a different temperament, one that tolerates ambiguity, one that values patience. Recent discoveries select for this temperament. They marginalize haste. Another emotional consequence emerges. As patience becomes necessary, frustration grows, not because progress stops, but because it slows. This frustration is real, but it can be managed by reframing expectation. Recent discoveries encourage this reframing. They show that progress may be non-linear. Insight may arrive in fragments. This fragmentation is unsettling because it resists narrative, but it is manageable. Another implication concerns identity again. How we see ourselves as knowers changes. We move from certainty seekers to uncertainty navigators. This shift is unsettling because it requires humility. But humility is adaptive. It prevents overconfidence. It encourages listening. Recent discoveries reward humility. They punish arrogance. Another emotional shift follows. As humility increases, defensiveness decreases. Disagreement becomes less threatening. Because certainty is no longer expected, this fosters collaboration. Collaboration is necessary in a complex universe. Recent discoveries encourage this culture. They require multiple perspectives. Another implication emerges. As collaboration increases, individual authority diminishes. Knowledge becomes collective, distributed. This is unsettling in cultures that valorize individual genius, but it is realistic. Complex systems require collective understanding. Recent discoveries reinforce this reality. Another emotional consequence arises. As authority diffuses, accountability increases. Claims must be justified. assumptions examined, methods scrutinized. This scrutiny slows progress, but improves reliability. Recent discoveries reward reliability over speed. Another implication emerges when we consider narrative closure. Many scientific stories end with resolution. Recent discoveries resist this. They end with open questions. This is unsettling for audiences, but it may be necessary because closure may misrepresent reality. Another emotional shift follows. As open-endedness becomes normal, satisfaction shifts. Satisfaction no longer comes from answers. It comes from alignment. Alignment between model and data, between expectation and observation. This satisfaction is quieter, but more stable. Recent discoveries cultivate this satisfaction. Another implication arises. As satisfaction shifts, disappointment diminishes. We stop expecting finality. We stop feeling let down by ambiguity. This acceptance is unsettling at first, but eventually liberating, because it removes pressure. Another emotional consequence emerges. As pressure decreases, curiosity persists, without urgency, without anxiety. This sustained curiosity is valuable. It fuels long-term inquiry. Recent discoveries encourage this sustainability. Another implication concerns wonder again. Wonder becomes less about spectacle, more about subtlety. The quiet realization that reality exceeds explanation. This wonder is not flashy, but profound. Recent discoveries deepen this wonder. Another emotional shift follows. As wonder deepens, fear recedes. Not fear of danger, fear of ignorance. Ignorance becomes acceptable, not celebrated, but tolerated. This tolerance is mature. Recent discoveries demand it. Another implication emerges. As tolerance increases, engagement becomes voluntary. We engage not because we expect answers, but because we value understanding itself. This motivation is resilient. It does not depend on outcomes. Recent discoveries cultivate this motivation. Another emotional consequence arises. As motivation stabilizes, science becomes less performative, less about spectacle, more about substance. This shift is unsettling in media-driven cultures, but necessary. Another implication concerns responsibility. As uncertainty becomes explicit, responsibility increases. We must communicate carefully, interpret cautiously, avoid overstatement. Recent discoveries enforce this discipline. Another emotional shift follows. As discipline increases, trust deepens. Trust grounded in honesty, not certainty. This trust is durable. Recent discoveries rely on it. Another implication emerges. As trust deepens, dialogue improves between disciplines, between science and public. This dialogue is slow, but meaningful. Recent discoveries require it. Another emotional consequence arises. As dialogue improves, polarization decreases, because uncertainty leaves room for discussion. Recent discoveries encourage this openness. Another implication concerns acceptance. Acceptance that the universe may never fully resolve, that mystery may persist. This acceptance is unsettling, but it is also freeing, because it removes unrealistic expectations. Another emotional shift follows. As acceptance grows, attention sharpens. We pay closer attention. We observe more carefully. Recent discoveries reward attention. Another implication emerges. As attention sharpens, insight deepens. Even without closure, understanding grows, not toward completeness, but toward richness. This richness is unsettling, but it is meaningful. Another emotional consequence arises. As meaning shifts, satisfaction becomes quieter, less about answers, more about engagement. Recent discoveries cultivate this satisfaction. Another implication emerges. As engagement deepens, science becomes less about conquering mystery, more about living with it. This coexistence is unsettling, but it may be the most honest posture. Another emotional shift follows. As coexistence becomes normal, fear transforms, not into comfort, but into respect. Respect for complexity, respect for limits, respect for uncertainty. Recent discoveries cultivate this respect. And respect changes behavior. It fosters patience. It encourages humility. It deepens curiosity. This respect may be the true legacy of recent discoveries. Not new facts, but new attitudes. A quieter, more resilient relationship with the universe. One that accepts unease as part of understanding. One that values process over certainty. One that recognizes that knowing is not about domination, but about dialogue. There is a point where reflection stops circling questions and begins to settle into posture. Not a conclusion, not an answer, a way of standing in relation to what remains unknown. Recent discoveries have been guiding us toward that posture, slowly and persistently. They do not demand belief. They do not demand fear. They demand attentiveness. Attentiveness is different from vigilance. Vigilance expects threat. Attentiveness expects complexity. The universe revealed by recent discoveries does not loom as an adversary. It unfolds as a presence that exceeds our frameworks. This excess is not malicious. It is structural. Reality is larger than representation. This realization reshapes curiosity one last time. Curiosity becomes less about filling gaps and more about maintaining openness. An openness that allows revision. An openness that accepts incompleteness. This openness is unsettling because it resists closure. But closure may no longer be the goal. Another subtle shift follows. As openness becomes central, certainty loses its authority. Not because certainty is wrong, but because it is temporary. Recent discoveries remind us that certainty ages. What feels solid now may feel provisional later. This does not invalidate certainty. It contextualizes it. Certainty becomes a moment in a longer process. This perspective is unsettling because it denies permanence, but it is also stabilizing because it aligns expectation with reality. Another implication emerges. When permanence dissolves, attachment changes. We become less attached to specific explanations, more attached to methods, more attached to inquiry itself. This detachment is not indifference. It is flexibility. Flexibility allows adaptation. Recent discoveries reward flexibility. They punish rigidity. Another emotional consequence arises. As attachment shifts, disappointment lessens. When explanations change, it no longer feels like loss. It feels like evolution. This reframing reduces anxiety, but it also removes the comfort of finality. Another implication emerges. As anxiety decreases, engagement deepens. We are no longer rushing toward answers. We are willing to linger with questions. This lingering is unsettling because it demands patience without reward, but it also opens space for insight. Another shift follows. As patience increases, observation becomes more careful. We notice subtleties. We attend to faint signals. Recent discoveries often emerge from such attentiveness. They are not obvious. They are quiet. They require listening. This listening is unsettling because silence invites interpretation, and interpretation invites uncertainty. But listening is necessary because the universe does not announce itself loudly. Another implication arises. As listening becomes central, humility deepens. We accept that our perspective is partial, that other perspectives may reveal different truths. This humility is unsettling in cultures that value certainty, but it is adaptive. Another emotional shift follows. As humility deepens, wonder transforms. Wonder becomes less about astonishment and more about reverence. Reverence for complexity, reverence for subtlety, reverence for the unknown. This reverence is unsettling because it acknowledges limits, but it is also enriching because it expands appreciation. Another implication emerges. As reverence grows, exploitation recedes. We stop treating knowledge as a resource to extract. We begin treating it as a relationship to maintain. This relational view is unsettling because it challenges instrumental thinking, but it may be necessary. Another emotional consequence arises. As relationships replace extraction, care becomes relevant. Care in how we observe, care in how we interpret, care in how we communicate. Recent discoveries demand care. They resist careless conclusions. Another implication emerges. As care increases, responsibility follows. We become responsible not just for accuracy, but for framing. How we present uncertainty matters. How we communicate limits matters. Recent discoveries force this awareness. Another emotional shift follows. As responsibility increases, confidence becomes quieter, not absent, but restrained. This restraint is unsettling because it contrasts with cultural expectations of confidence, but it is appropriate because reality is complex. Another implication emerges. As restraint becomes normal, spectacle loses appeal. We are less impressed by dramatic claims, more interested in careful reasoning. This shift is unsettling in attention-driven environments, but it may be necessary for trust. Another emotional consequence arises. As trust shifts, engagement changes. People engage not for excitement, but for understanding. This engagement is deeper, but less visible. Recent discoveries cultivate this depth. Another implication emerges. As depth increases, speed decreases. Understanding slows, but stabilizes. This slowness is unsettling because it contradicts expectations, but it aligns with complexity. Another emotional shift follows. As slowness becomes acceptable, frustration transforms. Frustration becomes curiosity. Instead of demanding answers, we ask better questions. This transformation is subtle, but powerful. Recent discoveries encourage it. Another implication emerges. As questions improve, inquiry matures. We stop asking what the universe is in absolute terms and ask how it behaves under conditions. This conditional thinking is unsettling because it denies absolutes, but it reflects reality. Another emotional consequence arises. As absolutes dissolve, meaning becomes contextual. Meaning arises from relationships, from patterns, from interactions. This contextual meaning is fragile, but resilient because it adapts. Another implication emerges. As meaning adapts, identity shifts again. We see ourselves not as observers outside reality, but as participants within it. This participation is unsettling because it denies distance, but it fosters connection. Another emotional shift follows. As connection deepens, isolation diminishes. The universe feels less alien, not because it becomes familiar, but because we accept our place within it. Another implication emerges. As acceptance grows, fear transforms. Fear becomes respect, not fear of harm, fear of misrepresentation. This respect is ethical. It guides behavior. Another emotional consequence arises. As ethics becomes central, science becomes more reflective, less about conquest, more about stewardship. Stewardship of knowledge, stewardship of interpretation. This shift is unsettling because it demands care, but it is appropriate. Another implication emerges. As stewardship grows, legacy matters, not legacy of answers, but legacy of approach. How we engage with uncertainty, how we communicate complexity. Recent discoveries shape this legacy. Another emotional shift follows. As legacy becomes a concern, patience increases. We think in longer terms, not just immediate impact, but sustained understanding. This patience is unsettling in fast-paced cultures, but it is necessary. Another implication emerges. As long-term thinking increases, anxiety about resolution fades. We accept that some questions will remain open. This acceptance is unsettling, but it is honest. Another emotional consequence arises. As honesty deepens, trust strengthens. Trust in science not as an answer machine, but as a process of inquiry. This trust is resilient. Another implication emerges. As trust strengthens, dialogue improves between disciplines, between science and society. This dialogue is slow, but meaningful. Another emotional shift follows. As dialogue deepens, polarization decreases, because uncertainty leaves room for conversation. Recent discoveries encourage this openness. Another implication emerges. As openness becomes normal, curiosity flourishes. Not curiosity driven by fear, but curiosity driven by respect. This curiosity is sustainable. Another emotional consequence arises. As sustainability increases, burnout decreases. We are no longer racing toward impossible goals. We are engaging thoughtfully. Recent discoveries encourage this pace. Another implication emerges. As pace stabilizes, reflection deepens. We think more, react less. This reflection is unsettling because it slows momentum, but it increases insight. Another emotional shift follows. As insight deepens, satisfaction changes. We are satisfied not by answers, but by alignment with reality. The satisfaction is quiet, but enduring. Another implication emerges. As quiet satisfaction grows, noise loses influence. Sensational claims feel hollow. Careful reasoning feels valuable. Recent discoveries reward this discernment. Another emotional consequence arises. As discernment increases, engagement becomes selective. We choose depth over breadth. This selectivity is unsettling because it limits exposure, but it enhances understanding. Another implication emerges. As understanding deepens, mystery remains, not as a threat, but as a companion. Mystery accompanies knowledge. It does not vanish. Recent discoveries confirm this companionship. Another emotional shift follows. As companionship with mystery becomes normal, fear diminishes. Not fear of the unknown, but fear of not knowing. Not knowing becomes acceptable, even valuable. Another implication emerges. As value shifts, science becomes less about certainty and more about care. Care in observation, care in interpretation, care in communication. This care defines maturity. Recent discoveries demand this maturity. Another emotional consequence arises. As maturity grows, humility stabilizes. Not humility as weakness, but humility as alignment. Alignment with complexity, alignment with limits. This humility is unsettling, but it is honest. Another implication emerges. As honesty becomes central, science becomes quieter, less triumphant, more reflective. This quietness is unsettling, but it may be necessary, because the universe is not loud. It is subtle, and subtlety demands quiet attention. This brings us to a final realization. Living with a quietly terrifying universe does not mean living in fear. It means living with attentiveness, with humility, with patience, with curiosity that does not demand resolution. The universe remains vast, complex, indifferent, but it also remains open to observation, to inquiry, to engagement. Recent discoveries remind us of this balance. They do not close questions. They open perspectives. They do not resolve mystery. They deepen it. And in doing so, they invite us into a more honest relationship with reality, not as masters, not as conquerors, but as careful participants, listening, observing, learning, and accepting that understanding, like the universe itself, may never fully settle. At some point, after enough questions, after enough revisions, after enough quiet discoveries that refuse to resolve cleanly, something settles. Not certainty, perspective. The universe stops feeling like a mystery waiting to be solved, and starts feeling like a reality that does not require our understanding in order to exist. This realization is not dramatic. It does not arrive with a revelation. It arrives gradually through accumulation, through patterns that almost make sense, through explanations that work until they don't, through discoveries that answer one question while opening three more, and slowly the expectation changes. We stop asking when the universe will finally reveal itself. We start asking whether that expectation was ever reasonable. Recent discoveries do not suggest that the universe is hiding something from us. They suggest that it is simply unconcerned with being fully known. This is not hostility. It is indifference. And indifference is unsettling because it offers no reassurance, no narrative closure, no promise that clarity is inevitable. But indifference also offers something else: honesty. The universe does not pretend to be simpler than it is. It does not adjust itself to our models. It does not resolve contradictions on our behalf. It continues behaving according to conditions that may exceed human intuition, and that forces a choice. We can insist on certainty, or we can adapt. Adapting does not mean abandoning understanding. It means redefining it. Understanding becomes less about final answers and more about continuous alignment. Alignment between observation and interpretation, between expectation and evidence, between humility and curiosity. This alignment is fragile. It requires constant adjustment, but it is resilient because it does not depend on closure. Another realization emerges at this point. The universe has always been quietly unsettling. What has changed is our sensitivity to that fact. As instruments improve, we do not merely see farther, we see deeper. And depth reveals complexity. Complexity resists simplification. This resistance is not a flaw in science. It is a feature of reality. Recent discoveries remind us of this repeatedly. They do not overturn physics. They stretch it. They do not destroy models. They expose their boundaries. They do not eliminate understanding. They contextualize it. This contextualization is uncomfortable because it removes absolutes, but it also removes illusion. The illusion that knowledge marches cleanly toward completion. Instead, knowledge curves. It branches. It revises itself. This does not mean progress is meaningless. It means progress is nonlinear. And nonlinear progress is harder to narrate, harder to sell, harder to compress, but it is more honest. Another subtle shift happens here. As certainty recedes, awe changes character. Awe is no longer rooted in spectacle. It is rooted in restraint, in the realization that reality does not owe us explanation. And yet, it allows us to observe, to infer, to learn, partially, conditionally. This permission is remarkable, not because it guarantees understanding, but because it makes engagement possible. The universe does not invite us to master it. It allows us to participate in observing it. That distinction matters. Participation implies responsibility. Responsibility in interpretation, responsibility in communication, responsibility in acknowledging limits. Recent discoveries demand this responsibility. They punish exaggeration. They reward care. They reveal how fragile trust becomes when certainty is overstated. And trust matters. Because trust is what allows inquiry to continue when answers are incomplete. Another realization settles in. Fear is not the appropriate response to a universe like this. Respect is. Respect for complexity, respect for uncertainty, respect for the possibility that some questions will remain open longer than we are comfortable with. This respect changes behavior. It slows us down. It encourages listening. It discourages premature certainty, and it creates space for better questions. Because when answers are incomplete, questions matter more. Recent discoveries are not terrifying because they imply danger. They are terrifying because they challenge a deep human desire, the desire for finality, for a moment when everything makes sense, when the map is complete, when the questions stop. The universe does not offer that moment. It offers continuation, and continuation requires endurance, curiosity without guarantee, inquiry without closure, attention without certainty. This is demanding, but it may be the most realistic posture available to us. Another realization emerges. Living with uncertainty does not weaken meaning. It reshapes it. Meaning becomes less about resolution and more about relationship. A relationship with evidence, with process, with reality as it presents itself, not as we wish it would. This relationship is dynamic. It changes as we learn. It deepens as we revise, and it does not end. Recent discoveries invite us into this relationship, not through answers, but through persistence. They ask us to stay curious even when clarity retreats, to remain attentive even when interpretation becomes difficult, to continue observing even when certainty dissolves. This is not passive acceptance. It is active engagement. Another subtle shift occurs. As engagement deepens, fear transforms again. Fear of the unknown becomes curiosity about the unknown. Fear of not knowing becomes comfort with learning. This transformation does not eliminate unease, but it makes unease productive. Unease becomes a signal, a reminder to slow down, to check assumptions, to listen carefully. Recent discoveries sharpen this signal. They teach us that discomfort often precedes insight, but insight does not always resolve discomfort. Sometimes it deepens it, and that depth is not failure. It is fidelity to reality. Another realization becomes unavoidable. The universe is not obligated to be comforting. It is not obligated to be intuitive. It is not obligated to make sense on human timescales, but it is observable. And that observation is extraordinary. that we can detect faint signals from billions of years ago, that we can infer processes we cannot directly see, that we can model behaviors far beyond everyday experience. These are not guarantees of certainty. They are opportunities for engagement. And engagement is meaningful even when answers remain provisional. Recent discoveries remind us of this. They do not diminish science. They refine it. They move it away from triumphalism and toward attentiveness. This attentiveness may be the most important outcome of all, because attentiveness keeps inquiry alive. It prevents stagnation. It resists complacency. It allows revision without collapse. Another realization follows. The most unsettling aspect of recent discoveries may not be what they reveal about the universe. It may be what they reveal about us, our discomfort with ambiguity, our craving for closure, our expectation that understanding should eventually feel complete. The universe challenges these expectations, not aggressively, quietly, persistently, and in doing so, it invites growth. Growth in patience, growth in humility, growth in how we define understanding itself. This growth is uncomfortable, but necessary, because the universe is not static, and neither is knowledge. Another realization settles in. We do not need to resolve every mystery to live meaningfully with them. We do not need final answers to remain curious. We do not need certainty to continue exploring. The universe allows for partial understanding, and partial understanding is still understanding. Recent discoveries affirm this. They show that insight can coexist with uncertainty, that progress does not require closure, that curiosity does not require certainty. This coexistence is unsettling, but it is also freeing, because it removes an impossible burden, the burden of needing to know everything. Instead, it invites us to know carefully, thoughtfully, responsibly, and to accept that some questions may always remain open. This acceptance does not end inquiry, it sustains it. And that may be the most important realization of all. If you've made it this far, you're already engaging differently. You're not watching for answers. You're watching for understanding. And that distinction matters, because this channel isn't about solving the universe. It's about exploring what we actually know, what we think we know, and what recent discoveries are quietly forcing us to question. If this way of thinking resonates with you, consider staying. Follow the channel, because the universe isn't done surprising us. And the most unsettling discoveries are rarely the loudest ones. They're the quiet ones that change how we see everything else. And if one of these ideas unsettled you, intrigued you, or made you pause for a moment, let me know in the comments. What discovery do you find the most unsettling, and why? Because understanding doesn't end with the video. It continues with the conversation.